Globant's premier scalable platform studios conference. I'm Sneha Rajput along with Harshala Gadkari. We are your hosts today.
A very good morning to all of you. Hope you all are doing good today. A warm welcome to SCNXT 2022 at Globant. We are so excited to have you today after 2 years. I hope you all folks are also excited as we are. So do you like our office?
Yes.
Our office itself is a great place to experience. So without wasting your time, I would now like to start agenda of the day.
We have some amazing talks lined up for you, and where the who's of the industry will be sharing their thoughts. Post which we have some yummy lunch in store. Post lunch, we will be exploring some innovations at Globant at our tech booths, interacting face to face with industry experts, and realizing the emerging futuristic tech and trends. Also, you will get a chance to participate in Design Shift Hackathon and showcase your architecture skills. Do remember that awards are a way to inculcate a competitive spirit. So we look forward to your active participation to make this conference successful.
So we are also giving you a chance to have some hands-on experience on blockchain. So you heard it right. So are you all ready?
Let me give you a quick overview of it. Here you can see the home page. We have already created a digital wallet and deposited some digital currency in it. Do note, this is just for your experience and educational purpose. So outside of Globant, it will be of no use. This is not just a simple application. By using it, you will get to know more surprises and interesting technical stuff. More detail about this app will be shared on our tech booths, of blockchain tech booths, sorry.
So moving forward with this conference, I would like to invite Shivraj Sabri to kick off SCNXT 2022.
Shivraj, fondly known as Shiv, heads Globant India's Delivery and Talent Center and focuses on the expansion of the transformational capacity at Globant in the EMEA and APAC region. One of the focus area for Shivraj has been around ready capacity to take up digital transformation challenges. I request you to please come on stage.
Thank you very much. Good morning, everyone. Good morning, everyone.
Good morning.
Okay. When you hear that kind of introduction, you're wondering if that's you. But good. I think, first of all, I'm very happy to see all of you here early morning on a Saturday. I know there could have been many more better things you could have done on a Saturday morning, like sleeping, but you're here. But take my words, this is going to be a great investment in yourself. You're doing a great investment in yourself. You may not learn a new technology today, you may not learn a new framework, but what is going to happen is this is going to open up your minds for new ideas. So this is going to be a good investment. And there's a couple of other things that will also happen and probably circle back to that. So that's one. The second is, I think, make this whole event a very, very interactive one. So if you have any questions, if you have any, let's say, doubts, start asking. How many of you at this point know what is the full form of SC? SCNXT. Some of you would have guessed, right? But if you've not, raise your hand and ask questions. Start asking questions. Scalable, right? Basically, scalable next. But the idea is, do not just wonder, ask questions. Make this very, very interactive. That's very, very important. What I want to just touch upon today is what is happening in the industry so far. What you are seeing is there is a huge need for reinvention and a huge disruption that is happening across the industries. I'll give you a few examples. When we talk about the world's largest taxi company, which company comes to our mind? Uber. Is that a taxi company? It's a pure software platform. Been very nice to a lot of people when I meet them the first time. The same way, when was the last time you went into a bank or an ATM? Very tough to remember. Other than some senior citizens, nobody goes to a bank these days, right? So, but banks have invested huge amounts in these amazing branches in the topmost locations across cities. So have ATMs, and these places are no longer required. What you see is every single domain is getting disrupted very, very heavily. So what I want to know from you is a couple of things. What do you think is going to be the next thing that will be disrupted the most? Anyone? Any ideas? What do you think it's going to be irrelevant and what's going to be disrupted? Anyone? Anyone? AI is going to be irrelevant? No, what we're talking about is what is going to be irrelevant and what is going to be disrupted. We talked about banks. Banks are going to change completely the way they are. Do you have any such examples? Education system, definitely I think needs to be disrupted. What else?
Gaming?
Gaming needs to be disrupted, definitely yes. Transportation, absolutely. Let's go one step deeper. What do you think would change in transportation? Think about it. Nothing has to be crazy, right? It can be anything. Right? So flying cars or transportation in a very different way. Fair enough. Very good. What else? Healthcare, absolutely, healthcare has to change. You were talking about that just today morning, yeah. Absolutely. What else? Currency is probably already disrupted, right? So, very true. What else? Shopping, great. Are you sure you want to go home today? Shopping? Okay, how do you think it's going to be disrupted?
Maybe interactive to have a shopping, now we have regards and everything. So,
Correct.
you can go ahead and.
You don't want to physically grab the clothes, you can see all of those. Great. So, a different way of shopping. That's true. So, I think every aspect of this.
Asset ownership industry.
Asset ownership industry. So, you saying it goes more rental or how does it happen?
No, the middlemen, those are.
Middleman goes out.
Yes.
No broker.com.
Yeah.
Excellent. So I think basically you're seeing there is a huge change in the way we are looking at our whole lives itself, right? We are moving very, very quickly from one way of doing things to the other. For example, the number of EVs that you're seeing, electric vehicles in terms of four-wheelers, two-wheelers, is tremendous. The adoption is very, very quick. Some of these vehicles are literally on fire. Come on. Sorry, Mami. Alright. So, it's an amazing transformation that we are seeing, and what we really want to see is we need to start thinking the business impact on this, right? That's very, very important. One of the areas, for example, that's going to be very, very highly disrupted is the whole area of war. In the recent war, what we've seen is the whole business of war itself is getting disrupted. What you see with Russia versus Ukraine and other wars is a basic change of big wins against small versus fast wins against slow. Earlier, every single war that you see, the bigger guy always won, or the bigger person always won. The smaller one always lost. That was the reality of war. Today, that is not the reality, because what is happening is we are moving away from data-based wars or information-based wars to intelligized wars. What is that? Basically, we used to have information. Okay, we have these troops over here. This is the central command. This is where your networks are. This is where your ammunition is. That was data-based wars. So you could actually target that. Very simple, rudimentary way of doing wars with data. Today, what is important is intelligence wars. It means you are actually using AI and using different ways to target specific individuals in such a way that you are going to be completely paralyzing the opponent. You know, you can literally target every single general in the opponent's army before even they think of a war. That's number one. Number two, you've seen these huge tanks move into Ukraine, right? There's a huge line of tanks. People would say, but at the end of the day, physical power is physical power. I mean, you have nuclear weapons, you have tanks, you have all these big aircrafts. You've seen the example of how useless they are proving. Russia moved in thousands and thousands of tanks in Ukraine. They thought it was going to be a 5-day war. The 5th day, Kyiv was going to be in their control. The 2nd day, most of their Russian tanks were destroyed by what we call as the Bayraktar drones. It's a very interesting story. I'm not going on a tangent, but for example, Turkey is a very interesting country. They sell these drones to Russia and Ukraine. So these guys should learn business properly. So it's amazing. So they have sold these very tiny Bayraktar drones. All they do is they go and you just have to, they are very, obviously they're unmanned, so they're drones, and on top of it, they're very, very cheap. One drone costs 1/100th of a tank, and one drone can literally destroy 10 tanks. You can only imagine the financials of war. So So Russia is literally curious of how to win this war, and right now they're in a very bad scale because they have been winning traditionally, and that is what is happening. So the whole game has changed. So the skills required to be successful have to change. This is very, very important. The game has changed, and the skills required to be successful have to change, right? So now if I ask, and just coming and expanding a little bit more on that, if I ask all of you to introduce yourself, how would you introduce yourself? A lot of you would say, hey, my name is so-and-so, I have X number of years of experience in so-and-so technology. So my name is Rakesh, I have 20 years of experience in Java, or I am a 12 years experience Node.js developer. And that is the unfortunate reality of this industry. This industry is forcing us to identify ourselves by the tools that we're using. Java is a tool, Node.js is a tool, Python is a tool. You're supposed to be someone who is creating end-to-end solutions, who is actually impacting the business industry with the help of these tools. Right? So you're using these tools for an end game. That is very, very important. For you, it is very important to understand that you should no longer identify yourself as just a Java developer. So the biggest area of disruption and the area which is going to be a redundant area, and I'm going to be a little provocative here, is a developer. The industry is not going to need developers very, very soon. And I'll tell you what, I don't need a Java developer with 12 years of experience because I can get that very easily. I have AI engines which can actually write base code libraries, so I don't need a developer. I need a solution provider. I don't need a developer. I don't need somebody who has an expertise in Java, I know, who knows in and out of Java. I can have an AI library which can do much better. So a developer is going to be the most redundant asset in the next 10 years. Remember this. So for you, it is very important to understand that you have to move from this area of being a developer to being somebody who's a solution provider, which means theoretically it sounds good, but how do you do that? You have to start thinking of the business impact, which means every time you check in a line of code, every time you write a requirement, how does it affect the end customer? What is the business impact? If you're able to translate this, if you're able to translate every single line of code into business impact, then you're actually becoming a solution provider. You need to start thinking, right? So for example, I think today we're going to talk about a lot of amazing things. We're talking about moving to the cloud, from cloud to sky computing, we're talking about microservices, React. We are going to talk about a lot of things, right? We've seen in the past how we flip-flop from processes, right? We used to talk about cloud processing. We said we have very good cloud processing, let's go to the cloud. Then came the self-driving cars. Let's go back to the edge computing because we can't have things in the cloud, right? I can't wait for the cloud to connect and tell me that let's not hit the guy in front of us, right? So, and now with better and better 5G networks and everything, we're thinking, let's go back to the cloud again. So it's important as a developer when you're thinking of this, what is the impact that is being created? This is very, very important. To think beyond the technology, think beyond what will I do to make the end consumer's life much better, and what tools do I have to make it better. So start translating every single line of code into business impact, right? So this whole flip-flop of whether we went to cloud, we went to sky, we went to edge, all these things are important, right? So again, I think it's very important that all of you make the most out of this. I know this is early morning, so my goal was not to put you all up to sleep. I hope half of you are still awake. Yeah? Yes, good. So then there's a lot of amazing talks coming up from here. I can see the whole team is here. I think it's amazing to hear from them. So I'm not going to take a lot of your time, but I urge all of you to start thinking big, and I urge all of you to start thinking in terms of business impact and start asking a lot of questions, right? Just after my talk, because these guys are asked. Okay? Alright, welcome to this amazing day. I know it's been early morning, but I can tell you this is going to be one of the best investments you have made this year. Right? Thanks, folks.
I request all of you to please keep your mobile phone on silent.
Across the world, companies have been challenged to remain in constant evolution, transform their culture and business models, rethink their customer experiences, and take advantage of new technologies such as artificial intelligence. Companies face the challenge to become augmented organizations. At Globant, we help pave the way towards this future. We work together with businesses around the world to define their way ahead and augment their capabilities to create new approaches for processes, products, and strategies. We create agile and resistant cultures where teams not only create change, but also adapt rapidly, creating exceptional experiences for millions of people. We walk along this road relying on a set of disruptors and accelerators driven by artificial intelligence. All of this boosted by our system of studios and agile pods, operating units that foster creativity and innovation. We are a native digital company focused on helping organizations rethink themselves and find their way forward through digital and cognitive transformation. The future is now, and it belongs to augmented organizations.
Reinvention moves the world forward. And that's what we do best. We are Globant, the company you probably don't know, behind many of the digital transformations you do know. Globant, seek reinvention.
Our next speaker has continued to grow and evolve through her journey at Globant. Her leadership has truly changed the way our scalable platform functions. Let us welcome our keynote speaker, the head of Scalable Platform Studio in Globant India, Sonali Palkar. Hey Sonali, it's all yours.
Hello everyone. Good morning. Good morning. Good morning.
Good morning.
I'm just repeating what she said. So welcome you all to SCNXT 2022. This is the fourth edition of SCNXT conference, which is getting conducted by Scalable Platform Studio in India. My name is Sonali Palkar, and I'm very happy that after long wait of 2 years, we are meeting again. I would like to know if you recall these pictures. Some movie, right? Almost 20 years back. I'm going to take reference of this movie. In this movie, they have shown the glimpse of future, how it would look like after 50 years. So how 2054 would look like, where transportation, medicine, communication, the way you wear clothes, advertisement, everything would be done in a very different way with a lot of new technology. I think movie makers predicted it would take 50 years, but you would agree that we don't have to wait 30 more years for this, right? We're already in the era where variables, augmented reality, the artificial intelligence for solving your day-to-day problems is already there. So this innovation has started just nearly 20 years of time. This tells that technology is really evolving at a rapid pace than what we might have imagined earlier. I will also take example of the recent crisis. Crises have enabled innovation, and last 2 years, when we were in pandemic, we are seeing that business as well as consumers are looking towards digitally integrated experiences, right? So this is further accelerating the innovation in technology. At Globant, we do innovation through our studios. These are deep pocket expertise, and Scalable Platform Studio basically focuses on server-side technology. The various solutions that we provide are the base for digital transformation of any industry. We are the largest studio in India and have expertise across various skills on the backend side. These studios look at emerging trends and we also build expertise on it. So that when we are providing these solutions, they are considering the aspect, how the technology is going to evolve and what would be the future needs, going forward. So we do these kind of tech pillars through the practices, and for this studio, the practices are based on these three fundamentals: strategize, build, and then evolve. And with the mindset of building future-proof platform. So strategize, basically this is a practice, strategic architecture concepting. We need to have deep understanding of a particular problem, what problem we are solving, and how to build a roadmap so that it cannot only solve today's problem, but it has provision for future needs. Build the augmented composable solution practice focuses on building different solutions with modern architectures. We heard about reactive microservices, cloud-native development, artificial intelligence. So how we can explore emerging trends in this technology so that it allows us to actually follow our philosophy of building future-proof platforms. And not to mention about evolve, platform evolution is equally important. The way we maintain and support our applications, it has to have the mindset of how it is going to adopt the new technology or how it's going to work even in future. So in today's conference, it's centered around scaling strategies for the future, and we have various tech talks by our experts where we will be talking about sky computing, unicorns, which is coming like the next two containers, and there are many other topics which are around these areas which are becoming or establishing as the next scalable solution for the future. So I welcome you all where you will be getting a very good experience on knowing these concepts. We are also having technical booths where you can see practical implementation of these, and also the hackathon, a very quick experience, a flagship hackathon that we are conducting where you can test your skills on designing and solutioning using the real world scenarios and also get expert advice. So I welcome you all to this conference, and I am also privileged to welcome our guests. They are going to speak and share their experience, Seema Joshi, Umesh Deshpande, and Samir Pokrana on scalable strategies and how they have been doing it in their organizations. So welcome you all, and stay tuned. We have many more things to come today. Thank you.
Thank you, Sonali. Now, I would like to call our first speakers of the day, Mitesh Dheman and Latesh Sarode. Mitesh is working as Technical Director with an architecture background as an enterprise solution architect and managing a technical team on complex problems. And Latesh is an architect at Globant, having experience as cloud practitioner. He is certified Kubernetes administrator and Azure 305 certified.
In this talk, we will be finding the evolution and emergence of sky computing and architecture, adaptability and live use cases around. With this, let us hand over to Mitesh and Latesh. Welcome Mitesh and Latesh on stage.
Good morning, everyone. Good morning. How are you? Fine. How is the sky outside? Is it bright or dark? Cloudy. Cloudy. Okay. So we'll be discussing about more bright sky and cloud after this session. We'll hear about more new things about the sky computing. My name is Mitesh and I'm working as a technical director with Globant, and then my pleasure to discuss about the sky computing. I'm here with Latesh, who is also helping me on a couple of areas of sky computing. Okay. So before we start about the sky computing, how many of you have been working in cloud? Just raise your hand. How many of you have visited the cloud? I'll give you a small journey to the cloud. Okay. So if you have not visited the cloud, I'll give you a small journey to the cloud. Not that cloud that your wife is asking for or your girlfriend is asking. It's all about the technology. Okay? So, Sky computing is something which is very buzzing these days, and there are multiple synonyms which is in the market. Multi-cloud, collaborative cloud, portable cloud. Have you heard about this before? Yes? Okay, wonderful. So, we will be discussing more about Sky computing, how it is making change in the future of cloud computing. We will be discussing about how it is organized the future of cloud computing. And by end of this session, you will have some information so that you can distinguish that what is the rumor, what is the story, and what is the fact. Okay? With that, I'll start my first session. Can I have a power? Okay. So last couple of years was very hectic for IT industry because of lots of innovation. Despite of the pandemic and because of pandemic, everyone agrees. It enforced lots of operation and business to see their digital presence, their presence on internet. And how it happened because of we have some cloud providers are giving a very fantastic services to be on cloud in very quick time. And that is how that the cloud has been very emerging and very fast emerging. So we would be discussing about like how the new era has been emerging, and we would be also discussing about like how we wanted to set our focus on the cloud computing. Okay, 3 logos on the screen. How many have recognized this? Everyone. Is it your dream company or it is a company that you wanted to visit? It's a services that you would be using in your day-to-day product or application that you will be building. So these are the pioneers in the industry from last decade and a half. They have been defined that what cloud is about. They created the cloud. Before this company, there was no cloud existence. Everything is in a box, a servers that you have seen in your curriculum books also, right? So before that, nobody was aware about the cloud. They created the cloud, they defined the cloud, and these are the companies which is one of the most valued companies in the world now. These are the companies which has been running most of the crucial application of the human civilization these days. Without that, it is not possible. So I have a respect of all these companies, and we would be calling now on what is the hyperscalers in our sessions. Okay? So, but what do you think? Like, because of the news and success stories and whatever you are hearing about from the different tech talks, is it every company in the world has been already on cloud? Or are you thinking only cloud is the only way to survive or prevail in the industry? No? How many of us think like we cannot survive without the cloud? Very few. Okay. So there are some key studies which has been happened by market leaders. I am going to quote one of the key studies by IDC. As per them, almost 30 to 40% of the companies have already moved their easy workload to the cloud system. But still 70 to 80% of the companies yet to be moved on the cloud because of certain reasons. And whatever they have moved in last 2 years, they are repatriating from the cloud. What were those reasons actually? Why they are moving away from the cloud? There are the 4 different points. Very simple terms. Performance, security, data gravity, and regulation and the cost. Last but not least, the cost. Everyone talk about the cost. Until you are not having a very competitive services, you will not be having a best price for you. Nowadays, so I would like to quote Sim actually that we are not a developers, we are not a Java developer, we are not a Python developer. We are the solution architects, we are the solution people. And there are many people who are sitting here, maybe coming up with their entrepreneurship, and they would be starting their own business. Best way to negotiate with the cloud, you just need to tell that I am already on another cloud. Then only they will offer you a discount. But there are the limitations. There are companies who have built their own proprietary solutions, and they are not allowing you to use other solutions. Giving you a simple example, in the last 2 years, everyone has been talking about serverless computing. AWS have their own serverless concept, Lambda. Google have Google Functions, Azure have Azure Functions. But being a developer, we are not allowed to write one code that can run all. For running the same code on the 3 platforms, you need to make changes in your code. There are APIs which you need to teach. Inter-cloud compatibility is not there. And this is how they are testing their services to them, and they charge you happy on it. And that is what we are thinking, like why Sky Computing is going to be in relevance in the future. Okay. So Mr. Paul Martin, actually, if you have not about it, is from the VMware, and the CEO of the VMware. He said like cloud is not about like what you are computing. It is all about, sorry, what do you it's all about do you compute, it's not where you do compute actually. So being a developer or being a solution architect or being an entrepreneur, you don't need to care about which cloud you would require to be. You just need to define the solution, create a disruption, reinvent the things, then everything is available. With this philosophy, there are many people and researchers and organizations that started looking for the future. I'm going to talk about the theory. I'm going to talk about a couple of examples, but there are still emerging. Okay, basic thing. Whenever we discuss about a new technology, we always have three words in mind: what, how, and when, and why. Okay? We are going to discuss about all three keywords, and it has small lines if it is visible to everyone or readable to everyone. What is Sky Computing we are talking about? It's the next gen cloud. Why we are talking about Sky Computing? It's the best cloud value for best possible cost. Again, cost. Being an entrepreneur or being a technology advisor, I've been talking to lots of startup companies. They only concern about the cost. They, for every solution or every problem, they have 5 solutions, but they concern about the cost. That is the solution that they are looking for in future. How it is going to be implemented? In layman terms, we are going to have a one unified layer which is allowing you to work across the cloud without making your code changes. Okay. Okay, so this theory started from 1960s. Mr. John McAfee has coded something for the future. Before you do your development, there are someone visionaries will discuss about the technology in history, and then they say like for the movie that Shonali has mentioned, it's for 2054, but people started getting an ideas and implementing those things. Similarly, Mr. John McAfee has mentioned like the computing, the cloud computing that we are talking about in 1960s is going to be commoditized. It's something like the telephone system that we are using. Have you heard about the ESPN, Public Switching Telephone Network? ऐसे घुमाते थे तो कॉल लगता था. Switching telephone system. Then we have a mobile era. Now we have a mobile portability. So they are thinking about like being a user, you should have a choice to code yourself. Whenever you will get the best value and best services. That is what they were referring in 1960s. Sky Computing is more about process services that introduce the future of the cloud. And there are many researchers who have started, and I'm going to quote one of the researchers from the, actually not one, actually 2 professors from the University of Berkeley who have used and they have put it their white paper, which is in implementation with a couple of institutes. Okay. So before we get into the why Sky Computing, small thing I've already given you, you need to understand how we evolved up to the cloud computing. So we started in 1950s with the distributed system, then mainframe system, cloud computing. Have you heard about the distributed system? Yes. It's someone Indian has invented, I think. Anybody know? Why I'm talking about invented? Distributed like, तुम मुझे ये दो मैं तुम्हें वो दूँगा. We'll manage with our neighbors. I'll give you tea and you give me sugar. And we'll both have one cup of tea. It's called a distributed system, but it is only possible with your neighbors. There are some challenges you cannot do with the person who is sitting in Pune and do with that person sitting in Delhi. So they emerge into the mainframe, then cluster computing, then grid computing, and then virtualization. So that's how we evolve. We evolve with the problem statement, we evolve with the things that we were piecing to evolve and develop ourselves. Okay? In 2015, when this cloud computing organizations has created this cloud and they defined the cloud, we are at a position that we can do anything, anywhere from anywhere. Because they are giving very simple UI to interact and adapt to new services. Okay, let's not get into too much of theory. Let's discuss about what is the reality. How many clouds, types of cloud we know? Your cloud, my cloud, our cloud, this cloud. No. We have five types of cloud which has been deployed in industry. We call it public cloud, private cloud. Public cloud is which you have all of this using. Anything that you have put in the cloud and is accessible to all the people. Let's say that I created a new website and I'm just introducing myself that I'm a bachelor person who is looking for a room or girl. Sorry. Okay, it is publicly available on public cloud. I can just put a page and put it to the S3 and I can publish it. While the private cloud is only for the people who are in my WhatsApp group that I'm giving that I'm available for my. Something that you are wanted to limit it, but it is still available on the cloud. We have a hybrid cloud. I can put it into WhatsApp group and I can put it in public. Anything. My picture will be publicly available, but my details are available to me only for a certain user. Hybrid cloud. Very simple example. I'm not going to get into too much details. I know that you might have already using, but I'm putting it in simple terms so that you can understand what complexity we are going to solve with this diagram. The multi-cloud. Okay, so this is the most interesting thing which is happening from the disruption happened due to pandemic. Everyone has been accidentally using the cloud, enforced to use the cloud. But there are countries who are not having all the cloud provider service present. Do you know that in China, Azure is not having their own service? Do you know there are companies who are not having presence in a couple of the countries? Because of that, they are accidentally using the cloud and they are accidentally using a different cloud, but they wanted to be on some different cloud. They started using multi-cloud. There are times that companies wanted to do in-house group. Let's say the Google has been working, definitely Google will use their own cloud, but he acquired a company who is using an AWS. Eventually they are getting into a system where they have a multi-cloud environment and they have to live it until they don't migrate. And cost to migrate is very high as of today. That is why the skyrocketing comes in the picture. Then we have HPCs. How many of you heard about AIML? What is full form of ML? MLM. Machine learning. Is it possible to run a model or train a model on your laptop? Is it possible? It is possible. With some limitations. That I'll give you only my opinion, I'll not give you billions of your opinion.
That's it, I didn't say earlier that I will do data mining, all those raw data, I can mine it and I can put it into my data flow models, in TensorFlow, whatever.
Right.
I can create a prediction and
right. Agree? So I'm saying that it is possible, but you cannot do what you are inventing if you have billions of information available on you. You would require high performance machines for it. Sometimes, let me give you more simplest example. Let's assume that you can run a model, a training model on your laptop, and if you are having 2 billion of records available, you will require to train that model and you will require time almost years of time to train it. I don't want you to wait for 1 year to train the model. If I would be having a 2000 server, I can adopt it and I can train the model in 5 hours or in 8 hours. Why not?
true means now quantum computing and
Yes.
those even Qualcomm inventing chips even also to
Right.
support such fast computing in our laptops even
Right.
also. So somehow I could say that yes, it's not going to be feasible in 5 and 8 hours, but in a day we're going to make it up.
Right. So we are talking very in general. Actually, if you wanted to train model which required lots of computing, lots of memory to be utilized, and you have huge amount of data to define a trend, it required time actually to run it. That's why we are having high performance computing, and then we have high performance grid also available. This is kind of a cloud computing I'm wrapping that can give you more time to invent instead of spending time on it. Like usually, I've been working in industry from 16 years now. That there are times that I used to have a GIF which give you, please grab your copy of a cup of coffee until we process your result, until we are showing the loading side. This is not expected. This is a user experience hampering. So everyone is looking to give a solution faster and quicker. If you know the solution, why not you use it? If you are having some challenges, that's what we are going to cover it in there. Okay. Again, I'm talking very generic. I'm not talking very specific. We will discuss if you have any questions after this session also. Okay. The last one, the cloud community cloud. Have you heard about this word before? You will hear soon. Narendra Modi is coming with the community cloud. In 2024, he will see that India will be having a nation cloud. It's nothing but what they are grading everything in one cloud. But what is community cloud? It is cloud which has been shared across the same domain and same industry leaders so that you can see the cost. Assuming that all the pharma companies have their own cloud, and if you wanted to share the information across them without spending additional cost, they have their own community cloud, the domain specific cloud. But Narendra Modi has always a great mind, and in 2024, I don't know that it will come to India cloud. Okay. So fact check. Again, I am going to quote the IDC information which has been recently published. I think, and as per them, actually, out of this 6, multi-cloud is taking very traction, and everyone is talking about multi-cloud. Why? Because they are getting a better price and better services, and sometimes they are giving the choice to take the best service providers. So 85% of the people are already moving or thinking about multi-cloud, and that is the area that is creating a deadlock situation. We call it vendor locking. If any cloud service provider is helping you to solve the simplest problem with their services, you are getting into the vendor locking. I refer an example of it. If you solve your problem with the Lambda, you cannot put it into Azure without making change. You are into vendor locking, and that is how they are charging you. Okay, so we have some challenges with multi-cloud, and why those challenges? Because of the proprietary services. We wanted to break down those walls of which is affecting the innovation, which is affecting the emergence of the cloud computing and the users of cloud computing. Okay. Again, I was talking about the 3 times, and this is again as per the one report, the AWS is still capturing more than 32% of the market, followed by Azure, Google, and Alibaba. And rest of the other vendors, you see the 37%. Plus, others still have 30% of market share. Who are those rest? Do you know, apart from these 3, any other cloud service providers?
Geo also have a cloud offering.
Geo?
Yeah, but it built on the Azure.
Right. Anyone else? Yes? Anyone said VMware? Before cloud, which organizations has been leading or they are pioneering into this industry? The oldies, Dell, Lenovo, HP, Cisco. They were the infrastructure backbone, or they were the people who have been giving all infrastructure before emergence of cloud. They have been living, they have been breathing the entire technology journey. The mainframe, the server that you were talking about, these are the leaders from the decades. I talk about a decade and a half only for the cloud computing. These people have been in existence from the 5 decades. They still have their own existence because they come up with their own clouds. Game is on. They are giving a big fight to this cloud provider. Again, the challenge is like everyone has worked on their own silos. They work in very disjointed way. You are not able to put your one code to another cloud. It is very costly. It is not that easy to move your data, your application from one cloud to another cloud. That's why we are talking about the stack computing. Okay. But wait a minute. The cloud service provider has also come into picture again. They come up with another plan B. Do you know how big is the cloud service market is about? Billions of dollars. So anybody who is running a $1 billion company, they always have a plan B. AWS have their plan B. Google have their plan B. Azure have their plan B. What they say, they will come to you, they'll match the hardware and software as per their data center, and then deploy it at your premises. They call it AWS Outpost. Azure having a stack hub. IBM having a satellite. Google is having an Anthos. They are giving the same experience that public cloud provider is providing on from your premises. They are competing with the oldies. Game is on. Okay. So that's how the multi-cloud environment has been comes into existence, and we are getting into area where we are not able to evolve and we are not able to efficiently evolve in some ways. So I'll give you some examples like how those use cases have been come into picture and how it's going to be done. The simplest example, if you are building an application and you want 100% uptime, it is not possible with any cloud provider. Most of the cloud provider is giving you 99.5% of availability at least. That means if you calculate, it is 4 to 5 hours in a year, their servers are down. You cannot live with it. You would require multi-cloud. You would require the applications of it. But because we are not interchangeable, you would require the cost to bear for making those applications run on multi-cloud. You would require to hire people who know AWS, who know cloud, Azure, who know GCP. You would require to have more people. Lots of energy and lots of cost. Another one, you won't. I mentioned about that lots of the cloud service providers are not having existence in all the areas. China I mentioned for Azure. Then what people will do? They will replicate the workloads so that if their user latency is very low, they will use Alibaba. They have their own servers on China. Okay. Very simple example. Let's say that we all become an entrepreneur and we wanted to start a $1 billion company, another unicorn we wanted to start. I know that out of 400 people who are certificate, at least 40% of people or 40 people out of this will create a company after 10 years. I don't know, in 2025 or 2050, we'll have your pictures somewhere in the Tom Cruise movie. that was a Tom Cruise, right?
Yeah.
So you'll have your picture in Tom Cruise movie. You are having interaction with Tom Cruise, but not in real. You would be in a metaverse. Future is something different that you not can execute. Okay, so let's say that we wanted to start a new application which we wanted to be a unicorn company. So you wanted to use a web application, the best service provider is AWS. But if your application is using a data and you wanted to use it for processing analytic, Google is having best service to offer. Similarly, if you are wanted to use Microsoft products like Microsoft Office, Microsoft SharePoint, anything which is related to collaborate, Microsoft is not allowing you to use those products from other clouds. You have to use it for Microsoft. Getting into the multi-cloud model. Again, getting into the vendor locking. What we are looking for? We are looking for the cloud that allows app to be written once and write anywhere. Written once and run anywhere. Okay, so what are the benefits that we are looking to this 500? We are opening doors for new capabilities. Assuming like NVIDIA is having a tie-up with Google and someone wanted to use other service with AWS, it gives you opportunity to work on with that opportunity. It gives you opportunity to use from another cloud. Better reliability. If you are having a distributed load, you will be having better reliability. You will be having a higher availability. I talk about 4 to 5 hours in a year, that is 99.5 availability here, giving in return. Okay. Better security. Old times again, if you distribute your X into multiple buckets, you will be able to save some of the X. Not all possible with something like if someone attack on one bucket or one cloud service provider, rest will give you support. Better security. Better performance. You will be aggregating all the services and using best of it as per your need. Lower cost. Definitely, if you are having interoperability, you will be choosing the best service at a very cost. You will be getting it. Last but not least, expansion of market. As soon as we break down these barriers of proprietary solution, you will see that lots of acceptance of cloud computing and this cloud computing, which increase the market adoption of this service. How is cloud computing is possible? We talk about lots of theory. Let me talk about how it is possible. I'll talk about simple terms. I'm a person of simple words. I don't have a big dictionary, so I use very simple words. Okay, how it is possible? With 3 terms. Compatibility, intercloud, and peering. These are the 3 fundamental things which all the researchers and institutes are looking and they are looking for it. It is in emergence and there are early stage of building a new compatibility layer, which will, I'm calling out its unified layer that you can write the code once and run anywhere. They would require compatibility into the cloud. They would require intercloud interaction and agreement to it so that you can run through it. and the last one theory. And I'm going to hand it over to Latesh so that he can explain with more diagrams so that you can visualize how it's going to look like. Latesh, over to you.
Good morning, all. Good morning. Yeah. Thanks, Nilesh, for setting up the context and putting information, lot of information basically, and talked about fundamental layers that are involved. Okay. So we talked a lot about what part of it. Okay. If we ever try to visualize a particular cloud that is running across multiple clouds, right? So if we wish to visualize the architecture of the sky computing, okay. So if typically I have a single cloud provider, I tend to use a lot of services in the same cloud because every cloud has their own set of APIs, SDK support, and a lot of other things, right? So I tend to mostly make use of the same cloud providers. We can say they are silo. Okay, they have no interactions or no even thought, none of the thoughts that are coming out of that, right? So we can assume that they are silo. So I have apps running in the cloud 1, okay? I have apps running in the cloud 2, okay? And then if we try to visualize, the very first layer is the compatibility layer, as Videsh have already explained. This layer abstracts away the services provided by different clouds, and it allows your applications to be developed on top of this layer, okay? And basically it enables the interaction between the multiple clouds. The next one is the inter-cloud layer. Okay. So this layer basically states that an applications which are running on top of this layer doesn't need to know on which clouds they are going to have their traffic routed. So for example, I have a couple of preferences or policies set up in my particular application that states that I want to make use of best things in the market for a cloud 1 in this case, or for example a TensorFlow job, okay, which might state that my data cannot leave Germany region, and I want to just complete it in the specified cost. Okay, so this is the benefit of this inter-cloud layer. And definitely the last part is the agreement, okay, the peer agreement, which states that, okay, I am enabling the data transfer and access across these multiple clouds, okay, and definitely thus by obviating, I'm trying to obviate the data gravity here. Okay. So before I talk about this slide, I would like to highlight one point is a recent Gartner survey on cloud adoption reveals that more than 80% respondents who are using public cloud, they are on multi-clouds basically. And many of the app developers see that as a competitive advantage. Nitish talked about vendor locking concept, right? So it becomes a competitive advantage for the particular vendor in order to provide the support. So I would like to just take out a couple of examples from these big giants, okay? For example, a Databricks, okay? So Databricks, which originally started giving the support in AWS, it took a lot of years to add the support for Azure, okay? All of these companies are, because compatibility layer is already emerging, we may call it as a set of APIs that are allowed your applications to be supported. So Databricks definitely took a lot of years in order to provide the support for Azure because it is not cheap. Okay, we need to get a skill expertise. We need to think about the cost aspect. So this is basically, as of today, the M into N problem is there as of today. So what is M into N? M is basically number of apps that are required to be running. N is number of clouds. So practically it is not possible to let your particular company and provide the support for different cloud providers. So these dotted lines indicates that there still a theme gap exists in order to provide the common compatibility layer. So as of today, we don't have it common, but definitely Databricks, Snowflakes have already started giving the support for these cloud providers. And maybe next is a Confluence. One of the important aspects that or strategic decisions that company may wants to choose in order to decide in which cloud I wish my jobs to be running in is data residencies laws. Okay? So if you see here, these laws are categorized based on different regulations. Heavily regulated, some of them are regulated, some of them are lightly regulated, and you see most of them are red. Okay? It means they are highly regulated and it becomes crucial to follow the data residency laws. Okay? That becomes a very strategic for a company to choose the respective cloud providers, and definitely their intention is to get towards multi-cloud, okay, and think towards the company or achieving the service which has more support across the multiple cloud providers, okay. And if we take an example of India, how many of you know what are the Cloud Act laws or about the data? Are we allowed to store our data outside of our geographical location?
No.
Okay. No, yes. Okay. So the Cloud Act law states that, okay, although you do computation across your borders or you get a lot of transfers here and there, your sensitive personal payment related data must reside in the respective cloud region, okay, in the respective demographic region, okay, and that is the bounded, and definitely there are heavy penalties involved if you don't follow to those norms. Okay, so compatibility layer is definitely emerging, and what I would like to highlight here is it's not something new. Okay, so it has a great relation with the open source project. Open source projects have changed their standards at many levels. As to over past 2 decades, this project have just enabled themselves such a way that you build your applications on top of them and you are allowed to choose any of the cloud provider that you wish to. Couple of examples are Linux operating system, Kubernetes for cluster orchestration, Dockers for application packaging, and then Apache for data processing, and so on. Okay, so what it means that you enable your applications to be built on these layers, okay, and you're allowed to choose anything that you wish to. Okay, this itself is an idea of emerging compatibility layer. Another example where we see this practically implemented is BigQuery Omni. How many of you are aware of BigQuery Omni? Maybe? Yes. Okay. Okay. So let me talk a bit about that. BigQuery Omni is a flexible system that lets you access and analyze the data across your cloud region. It has started giving the support for Google Cloud, AWS Cloud, and soon it is going to be there in Azure. Okay? So basically, it is a commitment towards their multi-cloud innovation system, and that's how the idea is, no matter where your data resides, you are choose to analyze or do analytics on top of data which is located on different memory shuffle tier, or even S3, or even other memory, or even on the local. So basically you see inter-cloud layer is already in place, and this layer is built on top of Anthos. Anthos is Google's meta control plane that lets you, basically it is off Kubernetes, and it lets you to access your data from different memory shuffle tiers, and it also orchestrates the loads around it. Okay. Yeah. So I would like to just conclude on the final part. I mean the future. Like how are we envisioning sky computing? Okay. We talked about the possible architecture. We talked about companies who have started adoption and have started giving the support. And how are we envisioning sky computing for the future? Right. So hardware providers might decide to create or have might reside in their own clouds. So if you take an example of NVIDIA is GPU specialized, okay? So they might reside in their own clouds, okay? And since NVIDIA is not specialized in SSD providers or hardware providers, where the Samsung is, they might have some partnership set up with them using lead fiber. Lead fiber is typically high bandwidth connection that every cloud provider uses. Right? And another thing is the nation cloud that Mitesh already explained. If we combine domain-driven clouds with respect to India region, that becomes a nation cloud, and that might have open connection with the other public cloud, and that's how you can visualize things that you wish your applications to be running in. So what I am trying to visualize here, at least I am trying to visualize here, sky computing as utility computing. So in typical scenario in the public cloud, where for example you choose one virtual machine, I have no idea in which hardware or which RAM or which company I'm going to use, right? I have no control on that. Here I have a complete control on these specialized hardwares, right? I may have another ones like Cerberus or Equinox in future, right? This way we can just circle everything and choose whatever we wish to. That's how we are trying to envision sky computing in the future. Any questions?
Basically, what is meaning of specialized cloud C?
Yeah. So specialized cloud C means, for example, I talked about NVIDIA, right? Their GPU gaming, correct? So currently they don't have their own clouds, but what they can come up with their own specialized cloud. We have expertise and we are giving you the cloud. We are free to choose our services because we are providing it in a cheaper cost, or maybe some other competitor like Samsung for SSD, you know, like Cerberus. Okay, this is any of the specialized cloud provider. Does it answer? Any other questions? Okay, thanks. With that, I would like to hand over to Mitesh for the last part. Thanks.
Thank you, Latesh, for explaining the architecture and the proposal. So, what we are looking for sky computing. So finally, I just wanted to conclude with it, like some challenges yet to be evolved, and those are the challenges more related to technology and the business things. But I am hopeful that sky computing is going to be a future one, because there are many organizations already putting their efforts. Apart from the technology and the business decisions, there are some constraints which is happening from the environment. I wanted to highlight last thing to conclude with the sky computing. Why it is required and why it is going to be introduced. If you see this diagram, it is came from the Climate IQ. If you heard about it, it's one of the leading world analytic company who has been tracking CO2 emission. CO2 is the responsible for all the greenhouse and the climate change that you are seeing. If you see their survey, recent surveys happened in last year, and as per them, the data centers CO2 emission is more than the aviation CO2 emission, more than the other shipping industry emission. It has been very much increasing. If you work in silo, you would not able to sustain and you would not able to maintain that CO2 emission. We need to control this, and that's the reason that sky computing is going to be in existence, and we are going to be into the collaborative cloud computing. Okay, and it is our role, it is our responsibility to save our environment if we are looking for a technology emergence. And that is the reason it is going to be enforced by laws again, and soon it's going to be notified across I think UNICEF and environment body has been coming up some rules and regulations so that it can reduce the data centers. And it is only possible if you are able to collaborate and intercode between the intercloud. Last but not least, I talk about the old timers, the Dell, HP, and those companies. They are coming with their own clouds. And as per Climate IQ only, the hyperscalers, the AWS and Google, they are still well maintained their CO2 emission as compared to the old data centers. So they are still enforcing the old data centers to collaborate more with the public cloud vendors, which is hyperscalers, and we are calling hybrid scalers. So still, there are many things going to be happen in technology, but it is going to be enforced by law soon. With that, I am going to conclude and will open up for question answer if you have any. And meantime, I just highlighted the 4 of the people from the research team who have done lots of hard work to make those content ready. So thank you for Dhyanesh, Nikhil and Shubham.
You said about the carbon emission, so I just need to know the few scenarios how these people are implementing and reducing the carbon footprint in this cloud computing environment.
Okay. So, if there is one person on the world wanting to use a cloud service provider, one person only, you don't require 3 cloud service providers. Let's collaborate to give service by one only. That is what is cloud computing about. If there are 5 people, you should have only 5. You don't require 50 competitors to provide. Let's collaborate. Whoever is available, whoever the data center is already having, you can use it. That's how they reduce. Instead of creating tons of CO2 emission, creating or building new data centers, you won't require it unless you are not able to utilize the data center capacity already available on Earth. That's how they are recommending. There are lots of things which is governed by the country laws actually. If they are using a data center, they are required to use the renewable energies, their own solar systems, their hydrocarbons, and there are many other things they are working on. Again, but they cannot shut down their data centers. Don't tell me like if you wanted to reduce carbon emissions, let's Sunday go data center band karo. It's not going to happen. Anyone else have any question, any thought? If not, I would be around only after this session also if you want to have any discussion, we would be here for any discussion. Yes, please.
As you see,
I would like to know your name because you are the third time asking questions.
Sandeep Mahapatra.
Okay.
Yeah. As you said, total cloud, Azure, Google, AWS, they leading right now, and customers like banks, they are quite hesitant to move from one kind of cloud to another cloud. Let me also explain over here compatibility, performance, security.
They are not hesitant. They want to move from one cloud to another. But cost of moving from one cloud to another cloud is tremendous. They have not anticipated that cost.
But I believe with the help of Terraform, they quite easily create the infrastructure and within no time. And they can immediately shut down the other cloud with that.
Yeah.
So,
are you saying that if I'm writing a big query and GCP, it will run automatically in AWS?
No, it won't.
If I'm writing an Azure function and it will automatically run in AWS?
Although you are just saying serverless computing.
So mostly the interoperability is required for the proprietary services.
I understand why I'm going to use the proprietary services. For example, you mentioned that I prepared my application and I just package it with the Kubernetes. And all kind of requirement that I need to do it, my application will do it.
Okay.
And with the help of Terraform, I'm going to immediately create the infrastructure.
Interesting. Okay.
Why should I require this proprietary?
Let me give you other perspective of it. If you would like to move in that way, there are many companies who are giving you services to reduce your cost of cloud computing. The Packer.com, if you heard about, the Cache.ai, these are the companies who are giving the services to reduce your cost of cloud computing, and you use the cheapest service whenever it's available. Even this service provider is all serving. But we are specifically talking about the services which are proprietary and they are not interoperable. That is only the problem that we are seeing there.
I got it. That if we get stuck with the proprietary thing, that initially if I'm going to build a service, and if I keep myself away from such of proprietary services to get used in my application, it could be helpful for me to jump from one cloud to another.
You will be having only 99.5% of availability. 4 hours in a year, your servers are down.
I agree.
You need to adjust yourself if you wanted to stick to one cloud only.
Still, you are free to choose. It's not that you have to, but you're more of like free to choose, and charges are there, and you can think it as a utility computing. if basically if you want, definitely there are ways to spin up everything using Terraform, correct? But when it's a matter of a choice, correct, then it makes a difference.
I agree on that. Thank you.
Good morning, first of all. My question is, as you said regarding India Cloud, one of the initiative of Narendra Modi ji. So if India Cloud comes, then will it be a public cloud or a community cloud? What kind of cloud it can be?
So I just give a thought like Modi ji will come for India Cloud because elections are coming and it's and I am a patriotic person. Whoever is giving the best services to nation, I'll vote for him. I'm not a BJP person. I'm not voting for him.
But what kind of cloud it could be if it comes?
We'll see. We'll see. I don't want to make a statement so that tomorrow all the three text me and that British is working for Narendra Modi.
Thank you.
So you mentioned that this sky computing is still in nascent phase.
It's still emerging.
Emerging. So if I correlate with 10-15 years when we started the virtualization,
Right.
at that time also it was like this concept which people were not able to correlate. But now we are habituated or we are familiar with these concepts,
Right.
like hypervisor and the Docker and all.
Absolutely.
So now if you see that everywhere it is being used and those were the pioneering who did the virtualization possible. So when we think about cloud sky computing, so which bodies are currently working to make this possible?
Perfect. Okay, so there are many people who have been contributing to this, especially for open source communities working on it, and the people, most of the CTO who wanted to dig into all the cloud service providers because they wanted to get away and get negotiated with. I mean, from last 2 years, if you talk about lots of CTO has been talking, CIO has been talking about, their PNL is increasing just because of we are paying very happy amount to the AWS. Everything is on AWS. They don't have a choice.
Yeah, but again, that will be like the same concept that we have cloud, that we have multiple cloud providers. So will it become a unicorn to provide sky computing like we have Docker?
No, it's going to be open source initiative. There is not going to be proprietary. They are allowing you to work into cloud and their services. Let me tell you a small thing that being a developer, I have always been actually when you have been given a task, you've been asked to write the best code which will run on all service providers. Is it possible to write today, if I will give you a task in next sprint, then write a code which will work on all cloud? Is it possible? No. That's why we are inventing this sky computing. And nobody will ask you to, even in this story, they don't tell you that this code is going to run on Azure, it's going to be on Google. Because that's a decision which has been made by CTO and CIO to save the cost for running that application. Especially for SaaS based or any other thing. Or taxi company that Shiv has mentioned. Uber is not fond of working on only one cloud. They're already using multiple.
But again, the underlying problem, I think it will not be solved if everyone is building their own type of solution.
No. So that's what the compatibility layer comes into picture. As soon as this layer is involved and there are different services already working on, write the code once and it will run on all the cloud services. That is going to be evolved and that is still in emergence. One of the examples like Latesh is mentioning database. They started with AWS, they started emerging a new compatibility layer, but it is only possible with the Databricks to run their application on multi-cloud using that compatibility. Think of it as Databricks open source that layer, it became very widely popular and people started using it. That's how we are envisioning it. It's not like we are not fighting with the cloud company. We are not fighting with any technology people who are doing research. We are fighting for making it more efficient and we are fighting for making it more cheaper and giving a choice to user to take from. Not getting into vendor of it.
Yeah, so that's what the underlying question was, that if everyone is talking and doing something on this Skype computing, they're providing their own solutions. So again, we fall into the same type of framework. Suppose if Azure is working on creating a layer which can talk about.
Let's not talk about the technology. Let's not talk about the technology. 5 years back, when you choose your SIM card, you're supposed to live with your mobile service provider. If you want to change it, you need to change your number. It is not possible in 5 years back. It is possible now because interoperability and portability is in this. Without changing a number, you can port your number to another service provider. That is what is going in this Skype computing in nutshell. Let it be Geo to come up with your 5G service. Let it be Idea to come with 5G service. But as a user, you have a choice to which platform you want. Your number is your application, wherever you want to run it. That's what we are talking about. And that is the governance model which many researchers and institutes is working on.
So that means that if I have hosted my services on Azure cloud, so I don't need to change the cloud, but just
you just need to focus on your creativity, your innovation, how you disrupt the market. Don't think about the cloud. Compatibility layer will take care for everything. Okay, so just in interest of time, I'll take a pause now.
If everything is so good about sky computing, there must be the second part of the point.
I was waiting for this actually. So, coin is always have a two sides of it. We discussed too many goods. The only limitation that we are having that there is no governance body which is involved. Possibly, but the only limitation that we are seeing that the efforts which has been put forward for the cloud computing has not been collaborative. There are government bodies and open source communities still working on it to make this happen and available for everyone. The only thing that they want is to collaborate first before they get scope and give a replacement for the cloud computing. But we are saying this is going to be future. I'm tech enthusiast. I have always been optimistic that what will change the world. That's what I'm talking about. Okay. So thank you very much everyone for taking this time.
Thank you, Mitesh and Latesh. That was an amazing and so interactive session.
Indeed, it was really exciting.
Undoubtedly, Latesh and Mitesh accomplished their purpose to create momentum towards the vision of sky full of computation rather than isolated clouds.
Yes. Our next session is about building scalable applications for the future. So you will get to know what is application scalability, why it matters, and its benefits.
It's my pleasure to introduce our next speaker, Seema Joshi and Samir Pokhrana from NICE. A seasoned product leader, Seema has 22 years of experience across product management, innovation, and entrepreneurial roles. Currently a global product leader at NICE, she heads X1 India product management and UX teams. A TEDx and keynote speaker, Seema actively contributes to various industries like NASCOM, SEED, and skill building initiatives.
And Samir comes up with almost 25 years of experience in product development, currently playing the role of Chief Architect for the CX1 platform and have extensive experience in research division, on-premise, enterprise system, and SaaS solutions. Seema and Samir, the mic is all yours. Please welcome on stage.
Thank you first of all for having us. I think fantastic way to spend a Saturday. How many of you have had this dilemma somewhere in the last week or maybe last night or this morning that I have to choose between shopping and investing in ourselves, like Shiv was saying? How many of you had the dilemma? We are in the week before Diwali. I had. Yeah, and guess what we've chosen to do? Yeah, and why did we choose to do this? I think we live in a in a world where it's possible to do that. And we'll talk a little bit about that in what we'll cover today. And at the outset, maybe I'll also set context. What Samir and I went through, I think this is a very deep topic, and there's of course a lot of work which is happening on a daily basis. And it's one of the most complex and fast-moving things that is, rapidly people are innovating on to make this a reality. In our conversation today, we try to keep it exploratory more than anything. So I think what we will have achieved, what will be a good outcome is if we have encouraged you to have more questions than answers, because that's really the goal. Of course, we are here to give answers. Feel free to reach out to Samir and me even later if there is something that comes to your mind. But really, I think we'll look at a few exploratory things. We'll of course talk about some fun things before we talk about. So the way we'll split the day, we'll talk about fun things, and I talk about boring things, and Samir will talk about cool things. He's a techie, and he'll give you more of what you need to hear. So what has been the one thing that most of you may have done in addition to the usual routine that you've had in the last 3-4 weeks? September, you had a lot of notifications on your phone.
Yes.
You are 2 hours away. The countdown is running. Midnight is going to happen. Yeah.
Yes.
Shopping. How many sales were running? What was in the news? The big billion day sale. Yeah? Anyone got a cool deal? Some of you? Yeah. I mean, this is literally insane, right? And just look at the headlines. And I'm going to read a few of those. 70% growth in premium mobile phones, just one product. They have had 50% more participation tier 3 cities. We usually thought e-commerce was an urban thing. We've all got used to it. Tier 2 is okay, tier 3 is what has emerged out of it. They had 1 billion visits. 11,000 crores worth of phones. How much did the buyers save? I mean, these numbers are huge, which is why I don't have it on the top of my mind and I don't want to risk it. 11,500 crores worth was saved by buyers in those 8 to 10 days. That's really insane, right? And this is shopping. We usually think that we're going to be about feed, save it, right? So it's been massive. And I don't know how many of you remember the thing on the bottom corner. The first sale that Flipkart had back in 2014 was a little bit of a, I wouldn't say disaster, but it was a little bit of a bummer moment, right? Many of us used to read the paper, like the physical paper. First entire page was the ad because the sale was going to launch the next day. Guess what happened was everyone went, logged in, and the app crashed. And from there in 6 years, I think this is massive. So, the scale in the future that we're talking is actually quite here. It's hard to say if the future is that or if we're living in the future. I mean, I think the trace is like really, really fast. We look at a few more stats. Just from this. And I'm not going to break the details here. And maybe it's not very legible from far, but I'll call out a few of those. And these are fun facts. The smartphones that were sold, so the total number was good enough to have like Burj Khalifa in Dubai, like at least 1,000 of those. The sofas that were sold would be equal the capacity of, I missed the numbers on the edits, but like I think a few hundred or thousand blockaded stadiums. This is all happening in that one sale, right? This is just insane. A watch was sold every 2 seconds. It's like a lot of consumer activity going on there. So these are real products, real businesses, real consumers making something happen in the 8 to 10 days of time. If you look at the business perspective, roughly around 11.8 billion GMV, which is in simple words, the amount of transactions that happened and that exchanged hands. It was made. A good amount of sellers had almost 1.5 times more money than they had made. We spoke about what we saved, and if you look at people like us who were buying, mostly people were spending in the ballpark of 5,000, 5,400. Now these are real money numbers, right? Each of us has a, sale is great, but we still have some, number in mind that we want to sell, but people are looking at those for making money. And then if you look at some stats more from, technology or a, infrastructure and an app perspective, 1 billion customer visits, that's a lot. We're talking about almost 1.6 million users that logged in, like per second. That's the kind of load that they were getting. And we can imagine what the response rate must have been like, because you were able to finish the entire flow that you were in, either in your discovery or selection or payment or whatever it may be. And there are a few more things. So I think you get the message, right? While there is a fun side to it, there is very clearly a business benefit for why companies are doing what they're doing. And there is clearly also a technical aspect of what is involved to bring this to life. And this is just a quick peek. Again, I think UPI has been the backbone. She was talking about it in the market. We've covered it in a lot of different ways. There is like an insane amount of scale that's kind of happening. And Samir and we were discussing yesterday. I think the scale at which UPI, just as an example, if you think of it, now Flipkart has gone from where they were to a certain number in 6 years, and I'm sure they already have a projection to, some X% is going to be higher, and their engineers are right now working to ensure that next year when they launch the sale, there is a team I'm sure has been spun off for that. And UPI doesn't know what is Flipkart's plan, they don't know what is Amazon's plan and everyone else's plan, but they know that all these transactions are going to hit me. So somewhere in the value chain, you may be an upstream or a downstream application also. And Samir and I were thinking, this is almost like, a big step and a plateau and a step and a plateau. That's how scale is going to look for some of them. And this is pretty impressive what we've been able to do. And if you peek a little bit into the B2B side of the world, right? I mean, I think consumer applications by nature are high scale because, it will be that way. For those of you who are more involved in building applications for businesses, Salesforce, of course, is one of the most prominent SaaS platforms out there. Of course, they have their own solutions too. And they have almost 150 customers worldwide. Now, I'll be able to find, so what does that even mean? Now, within these 150,000 customers, there may be some who have hundreds or maybe thousands or 10,000s of users, and that's going to translate back into the kind of user load they have, the transactions they do, etc., all the good stuff that we usually will get from a technical perspective. We have a number of applications within NICE, and these are just some numbers, and these are growing on a daily basis. So we have applications where we see almost 4.5 billion interactions going through the system, and that grows consistently. So that's also a problem that Samir and his team is trying to solve on a daily basis. 800,000 users. Again, it's a large scale, and when we have a user, so we make products for the customer experience. What that means is, if we have if our customers, when they're serving their end consumers, if they need to reach the company through a phone call, email, chat, bot, anywhere in the entire digital or non-digital interaction corridor, we provide the solution to make all of that happen. So this interaction can change really quickly, because think when we are in a Swiggy today, what do? We go to the app, we make an order, we see that it's not moving, we go do a chat, or maybe the bot comes up and says, hey, do you want a refund? Looks like there is a problem. There is already like 4 different channels we've patched in that, 10 minutes of the Swiggy coming home or the half hour of Swiggy coming home, right? So I think that's the nature of a little bit of that. So I think the reason to talk about some of this, and I'm sure you guys are thinking, why are we talking about all of this? Are we not going to talk about technology today? And is it not about scaling for the future? And this is what some of that scaling looks like. It will look different from different verticals. It will look different depending on the applications, and also the nature of consumers or customers that you may be working with. Now, if we just take a step back we saw a lot of different statistics, right? Seller statistics, revenue statistics, the number of goods that were sold, the amount of money that we as consumers were able to save. There was something for everyone to take home, so each of us was benefiting in a certain way. Of course, there is a market demand. And going back to my first question of how many of us had to make the choice between shopping and coming here. We could come here because some of us may have done lockdown last night, ordered something, it's going to come in the afternoon, you're going to try it, if it works great, if not, please take it back. In the old world, you would wait till 11 o'clock, and the more enthusiastic ones would be sharp at 11, right? Oh, because it's organized and it's sale day and it's chaotic, I don't know if they have my size or color, and if I get it, I won't find the changing room. If I'm lucky with the changing room, I won't get to the checkout. If I get to the checkout, my number in that customer, whatever loyalty system will not work, they'll send me to that queue. Oh man, we all relate to that. And look at what we do today. Entirely transformed, right? And we're able to do all of this. Of course, some of us will, for the joy of the experience, will still go back to stores, and many of us may do that in the afternoon today. But that's really what has happened. The market has changed. It's still that same good, it's still that same t-shirt, that watch, that whatever. Still the same company, but the way they're doing it has changed in a very different way. Of course, the revenues are increasing. I mean, how many of us are guilty of shopping for things we didn't really need? Yeah, because it pops up, because it looks nice, because I bookmarked it. Yeah. Positive customer experience. I think digital has changed this big time. The control has gone back to the consumer. Now, you guys are very young, but you have to trust me for this. Many, many years ago, when some of us were young, it was mostly B2B software. And it was, the software would tell you, this is how you need to work with me. The screens were hard, and you had to find your controls, or you had to write some script. Some people didn't have interfaces. But that was just how they ran. And then it was almost like, oh, the app allows this, and this is what I'm going to do. I think the shift has changed in the consumer's perspective in a big, big way. And of course, I think in reality, if you look at it, this has existed even in the past, and it's only become more popular and larger than anything is, I think, there are special events. It could be holidays, it could be sales, it could be, even I won't say boring, very important, finance software, very important for all of us. Payroll time has a peak, or if there is, quarter end year end closure, there will always be peaks. So irrespective of, what type of software we may be building, there will be seasonal activity which will be different than usual activity. And this is a more sophisticated way to be able to handle that. I think it's an understatement, the high loads and traffic data. And to be honest, in my mind, when I was getting ready to speak, I'm like, we talked about scale, and what scale should we talk? Because it's very relative, and it's growing by the day or by the minute. So we said, let's take a step back and let's just talk about principles, and maybe that's what we do. And new business models, right? The question about which is the car company or is Uber a tech company, and there are so many of those, right? There is MarTech and this tech and that tech. I think everything is filled with that because that's where we live and work today. So there are some very solid reasons, drivers, benefits why we do what we do, why applications are being built the way they're being built, and why companies are investing in technology for them to be better retailers, for them to be better banking institutes, for them to be better, restaurants or any of that. You can apply to any vertical that you like. We are really in the middle of a big shift, and actually we've been in this for a little while. Tech drives businesses and businesses drive tech. We have this dilemma, do you all agree? Somewhere we're in between. Some days it feels like I'm telling them, some days it's like you're telling me, I don't know what's going on. And it's not a very easy corridor to be in, but that's the reality. Yeah? Customer expectations, we spoke about how the power is really in the hands of the consumer. The consumer is telling, come meet me where I am. I'm in the middle of this application. This is my experience. This is my state. I need to discover something. I need to solve something. Do it for me now in my context. And technology never sleeps. Like, we can't shut the data centers on Sunday. Yeah. Now imagine it was okay for, that same chopper stop to say 11 to 9. By 8:30 they'll start turning off AC, some two lights will start going off, some sections will go, no one at the checkout. So they're slowly telling you, please start going home now. Same with restaurants when you're placing your order. The guy in Vaishali will come and tell you, sir, anything else, kitchen is closing. And you're like, you just give me the table, yeah? It particularly hurts when you go to Vaishali and they tell you that. But technology never sleeps. Now that's both good and bad. I mean, everything that, all the midnight sales were not even, no one thought of those that they would happen, right? So I think these are really some, we're living in the middle of some very big shifts. And again, I think unleashing the what technology can do. And cloud really has a big role to play in all of this. How scalable platforms, a lot of what Sonali was speaking earlier on, everything that can help make that happen is really kind of powering a lot of all of this. And then when you're in this journey, I think the question that comes is, okay, all of this is fine, I get it that this is important and we should do it, but how do we really go about it? What should we be doing? And I think one of the questions that comes up is again that same dilemma. Am I building for the business, or are we solving for a tech challenge? And it's going to be both, and I think which is why, and Samir will delve a little more also, I think from a technology perspectives and considerations and patterns, and how do you make some of those explorations, and what are the questions we should be asking ourselves. I'll just touch upon a few building blocks, more from how do you get started in the journey, or more from a business or user perspective. We all know of day in the life of your persona. You've all used that, or you've seen your product managers, product owners, or someone in the business telling you, hey, this is what the day in the life of this user, this retailer, this doctor, this someone looks like. Go build that for me. I need that dashboard. I need that notification. I need that something. Spend time to understand that. And then go beyond that. Don't just be okay. While the day is what it is going to be on most days, there will be the month in the life of that person, or even the year in the life of that person, because this is really going to help you elicit the special ones. Payroll day. On most days, they log in only to look at, let's say, if there is any regulatory or an exception or something in the finance controls which has gone wrong. Rest of the days, I don't need to worry. But before payroll processing, I need to know that things are happening. And then maybe on a certain day, the finance guys, and that happens only once in a month. And then maybe year end it's going to be very different. Same for the sales and any seasonal activity that you're expecting to see, depending on the domain that you are in. Be cognizant to understand that, proactively elicit that from your market, your customers, your users, depending on who you're working with. And that kind of leads to the second one also. Know your special days, because that's going to really lead into a lot of different days. And also into the currency of what that means. And when I say currency, what does it mean? So what is going to change on the special day? Does anyone want to take a guess on the big billion day sale? What special events must they have thought of?
Like the 1 rupee sale which MI used to host earlier.
Yeah. And it can be a business or a tech, any aspect, so feel free. Anything else that they would have thought is important for us to consider as we plan this?
Incoming traffic.
Yeah. Traffic of?
Consumers. There's a site visit.
Users. Okay. What is the user load I'm expecting? What else?
Payment load.
Payment flow. Do you want to go a little more further? Payment flow is correct. What else other than payment flows? Delivery, yeah. And delivery is also that tech, non-tech type, not in your head place now, right? I mean, everything is powered by even the last mile. What else? Success rate, failure rate, response rates. Sorry?
Inventory management.
Oh yes, inventory. Yeah, I mean, you say it's available and then you say no, sorry, too bad. I know. And that's happening like a watch being sold every 2 seconds. Do we realize how real time it has to be and how accurate it has to be? It's insane, and they're doing it. I mean, people are cracking it right now. I mean, in our country. So you already get a feel that each of you is thinking about something, and that certainly is a good aspect. But there are more aspects, which your neighbor is thinking, or your team member is thinking, or someone in the business is thinking. So do take the time to kind of elicit that and get that out. And that leads to managing your scaling needs. What does it mean for us to manage for scale, right? Take the time to figure that out, right? Because you're going to usually have like some leader come and say, guys, we need to have better scaling. Our application needs to scale better. We hear it all the time. I'm sure you hear it all the time.
Yes.
And then you're like, yeah, I mean, I already put that extra server, one cluster, some users. I have one more backup, payment gateway, whatever our lives may be, right? I mean, it may be in some context. It still doesn't get over. And the only way to make that happen is then to say, okay, can we agree what it might look like, and then we shoot for that. And I think which is why being able to see what your metrics of scale might be. And there will be some direct scale metrics, which usually is going to be a leading metric. Let's say users, right? I think being able to scale users is certainly the first step, which was hard in 2014 for Flipkart. But now they've been able to kind of not only just do that, but I think, and hopefully there is no government saying, everyone was able to find the most favorite dress, but payment failed. Yeah, we didn't hear that, and I think that's a good sign. So I think taking the time to identify some of that, and context is going to be so relevant. Context is king end of the day. And these are actually hard things to do. It's not like a one meeting, one thing. It's going to be very iterative, and you'll try out, and you'll see, and you'll learn. Just because someone did it, someone else should do it is never going to work. Just because this is for them, scale means 100,000. It might not be your answer. Your answer may be more, it may be less. Maybe someone is thinking throughput, but maybe for you response time is much more important than anything else. Imagine if you're building a trading app. I think there it's a different ballgame altogether then very quickly. And maybe there are some things which are only done very rarely, and real-timeness is not a big deal, and their answer is going to be very different, and it may be totally okay. Yeah. So if we kind of look at it, I think that was kind of setting the stage for a lot of different things that you could consider from a business or a user perspective. With that, I'd like to invite Samir, who will talk you through, when you're making some of these decisions as an architect, as an engineer, what are some of the technical considerations? And I can promise he has much better answers than me. So Samir, over to you.
Am I audible at the back? Okay. With Seema giving all the background of the why business needs high scale, what are some of the kind of requirements that come up, how are they used by end users? I think that kind of sets a very good stage to really talk about what we can try and do to really enable some of those use cases in the real world. This is one of the definitions I found for scalability. If you Google, there are actually many definitions. I like this particular one, primarily because it touches some of the key aspects of what scalability should address. Increase, decrease in demand, right? I mean, it's not only about scaling up, you also have to scale down. That's where the elasticity comes in, that's where increase, decrease in performance. It has to be a performance. You cannot just implement a functionality, but not have the same amount of performance. Your cost has to be in control. You can't just keep throwing money at the problem. That's cost is important. And then it has to be to manage the change. So something is changing in the ecosystem. UPI is going from 4.5 billion a year to targeting 1 billion a day in 4 years. That's change. That has to be a change that has to be accommodated by your scale system. And that's the demand, right? I mean, UPI is that we talked about. That's kind of. So it's really each of these key aspects have to be taken care of when you think about scalability. I'm just going to touch upon just a few kind of architectural pillars, what I would say. I don't know, it may not be readable as much from the back, but what I want to really point out is there are many pillars for scalability, right? For architecture. Scalability, if you look at it, is just one of them. It's just one item in here. There are other aspects, of course, in today's talk, we're not going to touch upon those because our focus is on scalability. But when you look at scalability, also think about reliability, it's another pillar. It's going to be equally important, like think of observability, how are you going to troubleshoot your problems, right, at scale. When you have 1 billion transactions coming in a day and you have that many metrics and that much logs to be looked at, how are you going to do your observability? But today we can kind of focus on scalability and maybe some aspects of performability because they kind of go hand in hand. One question for the audience. Now that you've kind of heard all the numbers that Seema has talked about, the different systems, what is your definition of scale? When you are told to build a high-scale system, what would be the numbers or thoughts that come to your mind when you think about it? Okay. more than the qualities, I was kind of thinking of what are the kind of numbers you kind of that come to mind when you think of scale?
Million users.
How many? Right. Okay, good point. So users, but depends on the context, depends on the use cases. Okay, so I think that this is a very important point that you made. Is context is important again. Seema talked about context is king. That's what this is about, right? When you think of scale, think about what are the personas in your system. If you're designing an application for an administrator to use, maybe hundreds or maybe thousands is a high scale. If you're thinking of B2C applications, that's where the billions and the trillions are going to be kind of fall in place. That's where the use cases and the personas are going to be very important. Timeline is important to also consider. How much time do you have to actually deliver a system? Are you developing the UPI application now for the next 5 years? Or are you developing for the next 10 or 15 or 20 years? Because if you look at UPI, it's being adopted by multiple countries now, even you're kind of exporting that technology, right? That platform is going to be used outside. Is billion going to be sufficient? Maybe not in the future. Do you want to design for it today? That's a decision to be made, right? Do you want to design for 50 billion a day? Maybe yes, maybe not. But that's where it's important to consider the time frame of deliveries as well. The parameters of scaling is again something to be considered. How are you going to scale up your system? Are you going to stand up a system and keep it running there? Are you going to keep scaling it up, scaling it down, which is typically what we talk about today in most cases. I mean, we don't even talk of the old legacy scaling kind of systems today. Right? I mean, but it's still around. Now, that's where the scaling parameters is going to be very important. Again, some of these we kind of covered earlier, but these are the things to be considered as the scalability requirements. When you think of kind of these challenges, you have to think of, again, just like personas use cases, what are your goals? Like we said, right? What is the time frame that you want to design your system for? How is it going to scale over time? Are you going to add more boxes? Are you going to add more resources to your system? Does each of your system scale in the same fashion? Maybe yes, maybe not. It depends on what underlying technologies you use there. So that's something to be considered. Performance is something you can never ignore because that's going to keep your cost in control. You cannot say that I'm only going to support, let's say, 10 concurrent users on one system, and for every 10 I'm just going to keep on adding new systems. That's not going to work. You still have to look at doing your coding, doing your application in a performant way. Right? You have to think of all the loops that you're going to put in. Is that the most ideal way? What are the data structures you're using? What are the algorithms? So performance is kind of equally important in there as well. This is the older copy. But that's okay, I'll talk through it. When we talk of scaling types, again, there's a third one missing here. I'm going to talk about it. So the old traditional way is really the vertical scaling approach. I don't know how many of you guys work on legacy systems, which are typically there in most of the enterprise companies. You would just think of adding more hardware to your existing box whenever you think of scaling. You think of planning for capacity, right? You think of what is my capacity requirement 1 year down the line? I need to budget for it, order for the newer hardware, right? That's where the vertical scaling comes in. That's how the legacy applications were and are still being used. The next phase of vertical scaling, which is kind of missing in this diagram here, is what is also called the vertical partitioning. Now what happens there, right? Now you may have your system where you have all your processes, all your databases, everything running on a single instance. Now, vertical partitioning is where you start to at least break down your systems in a way so that they just interact over the network. So you have your database on a separate machine, your cache on another machine, and your application on another machine. So you kind of start to break down those components. Now, typically that model works for legacy systems which are kind of moving towards the modern system. So you kind of go through phases out there. You don't, typically it is very expensive to go from a vertical scale to a horizontal system straight away because there's a lot of re-architecting, a lot of redesigning, re-implementation. It takes, it's a lot of times a multi-year process. Right? That's where you kind of get into phases, and that's where you get into vertical partitioning at times where you say these can be logically broken into multiple boxes and they all interact with the network. Right? And then your horizontal scaling systems, which is typically all the greenfield systems that you work on today. And a lot of you, probably a majority of the audience, when you start on new systems, will be thinking microservices, will be thinking serverless. They're all horizontally scalable systems, right? You even have databases now, which are kind of horizontally scalable. You can just add more read replicas. You have multi-master instances that you can set up where you have multiple writer nodes as well. You have partition systems. Think of all the NoSQL kind of systems, right? So those are kind of all the tools that are available today to really make this part a lot more easier. Typically, if you look at the okay, this I understand. That's good. If you look at the models of how do you develop a system, now typically this also ties in with what we talked earlier, which is time frames for delivery. Right? Typically, if you think at the development models, you can either do it step by step. So I don't know how many of you guys know Paytm when they started. How did they do their mobile recharges, right? When you as a customer call Paytm or make a request to Paytm, there were actual physical people sitting there. There was no technology backing everything. So there were people sitting there who would take the calls and would actually have their mobiles on which they would do the recharge, just like a mom and pop shop does the recharge, and it would get into your account. Now, at that point, they were not sure their platform is going to scale to the level that it is today. That's where they started. Now, that's where they took that first small step, where they said, okay, let me at least start and validate my business model, see if I really want to stay in that business. So this iterative model really kind of helps in that way. You start small, you get your kind of market validation, you get your feedback, you improvise on it, get to the next scale. Flipkart, with this scale today, still started very small. They started in the olden days. So that's where the iterative model really works well in the dynamic market that we are in today. And with the lack of knowledge of, you don't know how far it's going to evolve in the future. The big time model is where you say, okay, I'm going to plan for 20 years from now, and I want to design for that scale. I want to make sure this product will work for 20 years from today. Right? I have certain scale in mind, and you know what? I mean, this is a high risk state to be in. Right? Typically, I've not seen companies actually go with this model a lot, and none actually succeed. Because they just take so much time to get to market, they lose all kinds of momentum and kind of physics down. What is the, again, like Seema mentioned earlier, we're just going to give you tidbits to really ponder over. They should raise more questions in your minds. What are some of the patterns that can really help you design these high-scale systems for the future, right? Keep them loosely coupled. Typically, when you have very tight coupling between services, there are a lot of tsunami kind of effects, right? The moment something goes down, everything else suddenly goes down because everyone is dependent on each other, right? The first two are really sort of related. Isolation of services is also equally important. What is important is if you have a set of services that you are kind of providing as a part of your application, make sure you know what you're monitoring. When you know something goes down, you know what problem to actually address. When things are very tightly coupled, everything goes down, right? And you don't know what was the root cause. It's very difficult to find those and to actually restore your system because you don't know what actually went wrong. Keep them stateless. That really makes your horizontal scaling kind of better because you have to remember it's not just scale up, it's also scale down. The moment you attach a state, that part is stuck, right? You cannot actually scale down. It's going to make scaling down a lot more kind of harder. It's going to make load balancing a lot more harder if you have stateful kind of systems. Because let's say you have a kind of state for a login and the user logs into an instance. Now guess what? You have multiple microservices and that user is tied to each of those microservices and nodes of those, and you're just going to kind of keep scaling out because the users are coming in. Performance and scaling, they kind of go hand in hand, so always think of them together, right? When you look at your performance, you benchmark your systems, you think of, okay, I have benchmarked my system, now to scale, I should be able to easily extrapolate, right? Linear scaling is important. Make sure you validate those at every stage in your life cycle, right? From when you start to architect it, to the time you design it, to the coding level, at every point that linear scaling is going to be very important for your system to really stand that test of cost that we talked about. If it's exponential, then as your scale increases, your costs are going to go up exponentially, but your user base is linearly growing. So your profit margins are really going to go down because your costs are going to go down. Don't think of only your applications. Think of your dependent data stores, right? Think of your databases. Think of your caches. Don't just think of your application and your code that you're writing, because it's that entire ecosystem that needs to scale up and scale down, right? Not just the application. Think of, again, scaling, elasticity, up as well as down. So when you think of scaling down, now you should not actually drop users at that time. There has to be some graceful ways of handling those when you implement your elasticity in the system. Circuit breakers is kind of another kind of check to handle if you still have tightly coupled services. Now imagine, so I don't know, how many of you know what circuit breakers are? Maybe I can go through the concept. Okay, so I don't see a lot of facts. I'm going to just kind of cover what circuit breakers are. So typically what happens is, let's say you have a simple 3-tier application. You have your web tier, app tier, database. And your database starts to misperform, right? Now, where are you going to take action? One option is, you just cause your application to fail, and that's going to cause all your users to see a downtime. Instead, the circuit breakers are used to really say that my database is down, or it's kind of performing at a low it's giving me high latency, and that's why I can process a few users but not everyone. So that's where you kind of identify your application as to how much are you able to support, and you only process for that many users, the rest you reject, right? And at some point when you see your database come back to be healthy, that's when you kind of reopen the circuit and let the traffic flow. So that's where circuit breakers are. So make sure you think of these kind of patterns in your applications as well to handle the scale, because there are going to be times when you are going to see burst rate traffic. At that time, you want to scale up, but scales, elasticity is always comes with time. So it typically takes time, and when you have spikes of sudden traffic increases, you have to handle those, right? And that's where circuit breakers are also helpful to say, at least my current traffic I'm able to handle. The new ones, yeah, they will be supported when my new instances kind of come out, right? The circuit breakers also tied with the graceful degradation. Yeah, they kind of again go hand in hand. It's just that circuit breakers may be purely at a level of or how many users I want to support, how many I want to reject, versus the graceful degradation can go down to the next level to say, okay, I want to not allow use cases which are going to allow creation of users, but I want the other use cases to work, which are my core. If people are trying to, let's say, give an order, and I would have to show the kind of user information, I should be able to fetch the user information. That should continue to work. The creation of users can get impacted for some time. That's kind of the other different ways of dealing. These are some of the things to watch out for, right? Your bad APIs can actually severely impact the scalability. You have a non-paginated API, guess what? If you have a big tenant, you suddenly your one API is going to bring down your application. Data scans, again, that's more at the database level. You have the right indexes in place, you have the right sharding in place, the partitioning, you have hot partition, all those kind of aspects to be taken care of there. If you have memory caches in your application, that's the other thing to watch out for. As you scale up, your RAM requirement is going to be a vertical scaling approach, not a horizontal scaling. Even if your application is. Know your breaking point of the system. So when you do your performance testing, you should know where your application is going to break. That's going to help you define your elasticity kind of rules to scale up and down at the right time. The spike traffic, I think we already talked about. You need to make sure you factor in those even in your entire kind of life cycle. This I'm going to kind of just briefly touch upon because we kind of talked about benchmarking, scale testing, linear scaling, performance testing. The last two things, the chaos and the mock drills, make sure do those at scale. Typically, a lot of companies, they do mock drills, they do chaos testing, but that's really more at functional level. But I think it's important to do that at scale because a lot of problems, difficult problems actually come up in those two layers of mock drills and your chaos testing. These are kind of just some of the things that you need to do from a perspective of when you deploy and what kind of support do you do after deployment. So make sure when you do your kind of deployments, you have a canary model to really switch traffic eventually because it's very risky to actually switch traffic at scale because that's when problems can be very difficult to fix when you try to do that, which is where canary really helps. The others are really what you do around monitoring and alerting, which is all your key kind of scalability matrix is what you should always look out for monitoring and alerting. Yeah. Then the planning part again is something to watch out for in your environments as to that's going to keep your costs in control by doing the right infrastructure. I think that's kind of pretty much what we had. So we are running on time, but we can take a few questions. You talk about do chaos testing at scale. Can you throw some examples around what you really mean by that? Yeah, so typically when we started, like was saying, right, for our applications, we started chaos testing more at a, so typically when you go through the maturity curve on chaos, you don't go to production directly, right? So that's where what we adopted is we actually do chaos testing in lower environments as well as production. Now in production also, what we try to do is really try and do chaos testing at different times of the day so that you don't really, okay, we've actually not hit that maturity model yet on doing in production, but what I would recommend is really kind of doing it at different times. You have off-peak hours as well, typically based on what geography you're in, where are your users located. You typically find your off-peak hours. And that's where one option is to do chaos testing so that least users are impacted. In non-product, of course, is where we actually today do kind of chaos testing at scale, where we actually kind of mimic the production kind of load at the peak hours, and that's where we kind of do the chaos testing. Typically, if you think of chaos testing, that is recommended, or most of the mature companies, they kind of do it directly in production. But it's kind of typically a maturity curve that you go through.
Front end might be extra load, pattern,
Yes. So typically, whatever we talked of, typically is all on for the back end. For the front end, one of the things. So if you break up the front end into two parts, right? One is the actual delivery of your front end, right? Which is again probably hosted somewhere in your back end, whether it's CTM, whether it's on your own kind of web service. But that's kind of one scale testing that you still have to do as to how do you scale when you have a billion users just showing up, that particular web page showing up on their UI. Right? The other part comes more under the performance testing, where the front end testing you should still do on how is your UI performing. That's where the scaling is not as important because it's one user using that app once it is served to that user. Performance is important because how many API calls is it being, right? What's the response time from the backend? Now, typically when you do the performance testing of the UI, you should consider that your backend is in a scaled up mode, that is in the loaded mode, that's a peak time, right? So you still apply that load on your backend, but you do your performance testing for the UI. If you are loading your billion day kind of all the objects, how is that performing, right? Is it actually bringing up billions of objects at one time and then rendering it? Or is it actually, so those kind of performance testing is something that needs to be so feel free to reach out in case you have any questions. You can get our kind of contact information from them. And thank you, Globant team, for actually giving us the opportunity. It's good. Thank you.
Thank you, Seema and Samir, for your insights. Looks like the audience is already thinking about how they could scale their application to next level. Moving further, I would like to call the next speaker, Bhushan Saleh. Bhushan is subject matter expert at Globant India, expertise in implementing cloud-based high-performance applications. He has worked on many large-scale cloud applications too.
He's going to talk about the rise of reactive microservices and will also cover how to create highly scalable microservices with loosely coupled architecture to attain isolation level to make services autonomous. Welcome Bhushan on stage.
Thank you. All right. Oh, look at this. We have full house. Let me just test it out. Yeah, that's good. So in your slide, you see a small Terminator picture. So we are not going to talk about movies. I just wanted to mention. All right. Welcome everyone to Scalable Next 2022 conference. Today we are going to talk about microservice architecture and some of the limitations that we are facing currently. So if we look at the microservice architecture requirement, those are changing drastically. These days we are working with terabytes of data, petabytes of data with almost 100% uptime. And at the same time, our customer expect the response time should be sub-second. And sometimes while implementing such applications, the microservice architecture is not enough. So how can we solve this problem? Can we do something in a reactive way to cater those needs? Let's look at it. A brief about me, myself Bhushan Saleh. I am subject matter expert working with Globant in Microsoft technology. Today, in our agenda, we are going to talk about product development evolution. What exactly is the microservice? what are the different challenges we are facing with the microservice, and how can we overcome with a reactive way. And post that we'll take some Q&A. Okay. Okay, before getting into the main topic, I would like to know, while buying a car, what will you look for in your car? So what about you, sir?
Look for the size.
Okay, he'll look for the size. What about you, ma'am? Comfort. What about you, sir? Durability. So if you see, everybody has a different parameter. Some will look for comfort, some will look for durability, some will look, hey, I want a 7-seater because my family is big. So what are these things? So once you look for all these things, you go to a showroom, buy your car, you start driving it. How will you feel? Good? Why? Because you are getting what you are expecting. And what is that? That is the experience. We are looking for experience in each and everything. If you are eating a pizza, you look for experience. If it is not hot enough, you will feel, hey, what kind of pizza is this? If you are watching a movie and if it is boring, you will feel, hey, the experience is not good, man. The movie is not good. So that is the main thing that we are looking for in each and everything. And same goes with our customers. They are looking for the same thing. They are looking for the experience in the application that we are going to deliver them. So on a very high level, if we need to talk about this experience parameters, what are those? Being responsive. So any customer, if they want any application to be there, they want the application to be responsive. They should be able to access it immediately. There should be a response in the timely manner. There should not be any lag. So that is about responsive. Then features. This is another important thing, because an application without features is of no use for our customers. So they'll be looking for all the features that they need to use that application to solve their business use cases. Then comes the most important thing, highly available. Whatever may be the size of the application, if 10 people are accessing or million people are accessing, everybody wants their application to be up and running all the time, no matter what happens. So that is all about the availability. Now if we look at this, so in order to cater all those needs, the evolution of development happened quite drastically. There are a lot of changes happening over the period of time. So if we look at these trends, and if we talk about in early 2000, initially the user base. Earlier application user base was okay. So we had a few thousand, few hundred users accessing the application. But these days, you will have giant application where 1 million concurrent user will be accessing your application. For example, Netflix or Hotstar. If there is a match, cricket match, almost 1 million plus people will be viewing that match. So the user base has grown drastically. Then comes the complexity. Back in old days, when we were developing the application, those were developed in the silo, ek dabba. Just like, I want to implement this business process, and that's it. So the main focus was, I need to satisfy need for this particular department, and that's it. But nowadays, we want application to integrate everywhere. SAP, Ariba, somewhere else, these integration, that API integration. So that complexity of that application has also increased too much. And now if we talk about the technology, earlier, let's say 10, 15 years back, if you need to develop a web application and you have a Java developer, you can do it with that Java developer. Design UI, design API, design database access layer, you are done. But now you have n number of options. For creating UI, you can use React, you can use Angular. For backend, you can use Java, you can use C#, anything. So the technology stack has been evolved and it is still evolving. Then the data. Data is growing like anything, because somebody has said data is the next gold. And if you see, earlier we used to work with the gigabytes of data, and now it's terabytes, petabytes, and it is growing day by day. Then comes the availability. Now if you remember, earlier availability was not the biggest concern, because you will be mainly focused on how exactly you are going to digitalize your business process. If you recall, back in old days, if you wanted to do any online transaction in some net banking app, and if it is not working, will you be bothered? अरे नहीं चल नहीं रहा है, चलेगा थोड़ी देर बाद try करते हैं. But now, today, if I ask you to scan a QR code and pay via GPay, and it is not happening, then you will be pissed. अरे क्या है? The bank site is not working and it is not up and running. So availability has become very, very crucial for all the application and for all the customer. So that is the evolution. Now, how can we address this growing expectation from the customer? So we should be able to seamlessly onboard our users without any performance degradation. At the same time, we don't want to burden our developers and architects. Hey, there is too much complexity, you need to develop it, irrespective of anything. We need to make sure the complexity can be developed quite easily. We need to make them enable to do that development quite easily. And at the same time, people are spending a lot of money, a lot of their brain, a lot of their time to develop this framework which offers you a lot of flexibility and a lot of functionality. Instead of writing everything from scratch, let's try and use those technology stack. Try to consume as much as possible. So you should be able to use multiple technology stack. And the most important thing, you need to make sure your application is highly available and responsive. Now, to fulfill all those needs, if you are thinking about architecture, what comes in your mind? If you are thinking about monolith, maybe if you want to have a very simple application which need to be catered 10, 100 users, it might work. If you are thinking about SOS, service-oriented architecture, where you want to have separate services, but you want to cater few thousands of users, maybe. But if you are thinking about microservice architecture, then I think you are on the right track. So let's take a look at it. What exactly is the microservice architecture? So if we take a look at the definition, it's a service-oriented architecture which is loosely coupled and has a bounded context. So if you see, we have three separate sections. What does that mean? Service-oriented architecture means you'll be creating each service separately, which will be communicating over the network. Then it will be loosely coupled, so you'll be able to update them independently and you'll be able to deploy them independently. Then the bounded context. That means it will be self-contained. If you are changing something in one service, that is not going to affect other services. So that is about microservice architecture. Now, what are the different advantages we are going to gain with the microservice-based architecture? So you will be able to do independent deployment. Irrespective of any other service, you will be able to deploy your services. Then you will be able to use mix and match of technology stack. For better usability, for UI you can use best possible UI framework. You don't need to write everything in Java, JSP and servlets. Those days are gone back. Then independent development. As we'll be using different technology stack, you'll be having separate teams which will be skilled on those particular areas. So your teams will be separate. You will not have any dependency between the teams. Then of course, as we'll be developing it separate services, the fault isolation will come in picture. That way, if one service is down, it will not impact the entire system. And then the granular scaling, where if one particular service is having a particular load, then you will be able to scale that particular service only. So these are the different advantages of the microservice architecture. Now we are talking about a lot of theory and it might get some boring. So let's try and implement this microservice architecture with a use case. It's a pretty generic use case where you need to transfer amount from account A to account B. Okay, let's try and implement in a synchronous communication way. So let's say Bhushan want to transfer 10,000 to Priyanka's account. Okay, so far so good. Now I have three services: user, account, and ledger. User will store the information related to user. Account will store information related to account, like your balance, how much balance you have, any loan amount, and so on and so on. And the ledger will be responsible for keeping track of all the transactions. Now, I initiated the payment, make payment, trigger payment, create transaction, I got the response. Happy path? Good? Good for everyone? Good for developer? it's a synchronous communication. There might be some issue. Let's say, if my ledger service is having some problem, it's not behaving the way it should be. In that case, I'll be not able to get my response in time and my transaction will not get completed. And if eventually ledger service completely goes down, my entire cycle will collapse. I won't be able to do any transaction. So this is the drawback with the synchronous communication. Now let's try and look what are the different limitations that we are facing. So when you are doing a synchronous communication between the service in the microservices architecture, there is a chances of failure. And when you are considering synchronous, you are creating a point of failure. And at the same time, you will be getting into the issue where there will be issues with the transaction in the distributor system. As earlier, the two service has already completed their work, but they have to roll back because third service is not working. Right? Now let's take another example in the real world. For example, sir, what is 14 into 256? Okay, it's too difficult. We need calculator to do that. But have you observed one thing? When I ask him question, have I paused? Has my brain stopped working? I'm still talking to you guys. So in same way, means I'm communicating with him in a asynchronous way. So if I'm not doing that communication in the real world, why not I should implement the same thing in my software? Because the same thing is going to fail one day or other day. So synchronous is not a good way to implement it. Let's try and implement it in a asynchronous way. So same use case, again Bhushan need to transfer 10,000. We have same three services, same request transaction. So now, instead of calling those services directly, we are going to place a message broker, which will have separate queues for each topic. So every service, if they want any response, they are going to send a message to a queue, which will be picked up by the responsible service, which has subscribed to that message, and then process the request. And that way, we'll be able to complete our transaction. Happy path? Good. It is going to work. So asynchronous is the way to go forward. Maybe or may not be. There are still chances. Ledger service, it still has the issue. Nobody has fixed it. And it is still not behaving the right way. And sometimes it goes down. What happens? All the messages that has been sent in that queue start getting piled up, and still poor Bhushan is not able to transfer 10,000 to Priyanka. My use case is still not complete. Still there will be impact on the transaction those are getting carried out. So now, eventually if the account also goes down, then it's utter chaos. Now we will say, array synchronous is not the right way. Asynchronous is also not the right way. And what should we do? What is the solution for this? Reactive. So let's get into our main topic. What is a reactive microservice? So first let's try and understand the word reactive. What do you mean by reactive? Reactive means responding to a stimulus. For example, if I punch a wall, what will happen? I'll have pain in my hand, right? Because I'm not a Superman, right? So in this case, the punching to the wall is my stimulus and the reaction, pain in my hand. So same thing. While designing your system, it has to be designed in a reactive way. Load increases, scale up. Load decreases, scale down. There is a failure, let others know that you are failing. So that is the main principle of being reactive microservices. So let's take a look at the definition of the reactive microservices. What exactly is the reactive microservices? A microservice communicating over the process boundary using asynchronous communication. And at the same time, it has been decoupled to have a separation in the failures. So if we try to break this definition in two sections, the first section says your service should be autonomous and it should communicate with the other service in an asynchronous way. At the same time, the second section talks about the isolation. And it also talks about you should have the failure separation. So enough of definition. Let's take a look at if I need to implement any microservice in a reactive way, what do I need to do? Because that is the main question that we'll be asking for. So what are the different principles that we need to follow? As per the Reactive Manifesto, if you want to make any particular system in a reactive way, you need to follow these principles. Elastic, responsive, resilient, and message driven. So what are those? Responsive. Your system or your service should be able to respond in a timely manner. There should not be any bottleneck. If there is any error, it should respond in that way. Hey, there is an error in this particular functionality, I will be not able to execute it. So that is about being responsive. Then resilient. What do you mean by resilient? If there is any failure in the system, it should not get propagated. And that service should be able to contain that failure. So that is called as resiliency. Then elastic. Load increases, you should scale up. Load decreases, you should scale down. But in a reactive way, you should be independently scale yourself. There should not be any dependency. The architecture should be decentralized. So you'll be able to scale independently. So that's about being elastic. Then message driven. Of course, to avoid any dependency on the services, you need to be message driven where you are communicating with the other services using a asynchronous way. Now we are talking a lot. We are talking about microservices, we are talking about different reactive principles. But what exactly is this reactive microservice architecture? Is it some different framework that we are not aware, or we are aware but we are not able to use it? Or is it some NuGet library or some library that we need to include in our project? Or is it the new offering from any cloud? No. So reactive microservices is the architectural pattern that we need to use on top of our existing microservice architecture, so that we'll be able to achieve the isolation so that there will not be any failure in the system. Okay? Now, if we look at the DNA of reactive microservices, what does it say? It should be autonomous. Autonomous means it doesn't mean that it should execute on its own. It means it should be independent of other services. It should be able to scale itself on its own. There should not be any dependency. It should have a single responsibility. There should not be a burden on that service to implement additional thing. Then maintain own state. So basically, let's say you have a service, it goes down for 10 seconds and it's offline. And after 10 seconds, it comes online. And during that 10 seconds, there are a lot of activities it is supposed to do, like create entity, update entity, and delete entity. So in that case, the service, once it's back online, it should be able to consume all those events in the same order and restore its state. So that in future, when it starts serving the request, that time there should not be issue with the data integrity. So far so good? Okay. Then asynchronous message communication, as we saw, it has to communicate with the other service in a asynchronous way. Then the most important thing, isolation. Any reactive microservice we need to create using the isolation. So isolation is the key for creating any service in a reactive way. So let's deep dive into isolation. So what are the different principles of isolation? So isolation can be categorized into four different principles. Isolation in state means you should be able to access your service using only its endpoint. There should not be any backdoor access like database or file store or anything. So that is isolation in state. Then isolation in space. The services should be able to deploy independent of each other, and at the same time, if you change the location of the service from one place to other place, still I will be able to consume the same service in the similar way. So that is isolation in space. Isolation in time. The service should be able to communicate with the other service using asynchronous message. So it might introduce some eventual consistency. Then the last and the most important thing, isolation of failure. So you need to define the failure zone. You should be able to define this service could fail here and we need to mitigate that. So that is isolation in failure. Now we saw What exactly is a reactive microservice? We saw what are the different reactive principles. We saw what are the isolation principles. But when are you going to tell how to implement it? Right? So let's try and look into some of the techniques that you can apply in your microservice architecture to implement the reactive way. So the first technique is bulkheading. You see a ship? Everybody knows a cargo ship, right? A cargo ship is a big ship that carries a lot of container and it travels from one continent to another continent. Now, travel by sea is a very difficult journey. You might get into storm, there might be some accidents, and it might put some hole in the hull of the ship and water starts coming in and your ship might sink. Right? That could be one possibility. So this was the problem that shipping industry was feeling with the cargo ship, because if the ship is sinking, there will be losses in the millions and also the lives will be lost. So how they overcome that particular problem? So you see the diagram of the ship. Here, instead of creating one large compartment, they created multiple compartments, 1, 2, 3, 4, 5. And these compartments are isolated from each other. Let's say there is a damage in compartment 1 and water start pouring in. Still the ship will not sink because other 4 compartments are still intact. And in that situation, you will be able to take your ship to the dock and continue the repairs. So same thing we need to apply in our architecture. We need to create this compartment for each and every service. And we need to isolate them so that if one service goes down, it will not take down the entire system. So that is about bulkheading. Then circuit breaker. If there is an issue with the service, it should respond in the timely manner. And to avoid any timeout error, we'll be implementing circuit breaker. Then message driven. As we looked at it earlier, while communicating between 2 services, you need to be using a asynchronous message. That way, you'll be avoiding any dependency on the service. So that about being a message driven. Then autonomous. So not like that cycle, it is running on its own. It's not autonomous in our services. The autonomous means there should not be any dependency between the services. It should be able to run it on its own. So that is about the autonomy. Better autonomy will allow you to have independent scaling and in some cases infinite scaling. Then the API gateway. It's a very famous picture from Paris. So there is a gate, lot of roads are meeting. So gateway is the same concept that we have. So you'll be implementing this lot of complexity in the microservices. Now there will be overhead with your customer to consume those endpoints. To avoid that particular issues and make it more isolated, we'll be using the API gateways. So now we looked at a lot of different things. We looked at what are the limitations with our earlier implementation in the synchronous and asynchronous, and also we looked at what is the reactive way to implement it. Now let's try and implement our same use case in a reactive way. Okay? So the same poor fellow, Bhushan, he still need to transfer 10,000 to Priyanka and it's not yet done and he's really pissed now. Now, in order to develop this, again, we have 3 services. So far so good. Everybody's with me? Yes? Okay, great. So 3 services having user, account and ledger. Each service has its own entity. User has user, account has account, ledger has transaction. Okay? Now we'll be using a message broker Kafka or anything equivalent which will be storing all these messages. Then what happens? If user service creates a new user, it is going to publish that particular entity onto the streams. Where I'll come to know like, hey, new entity has been created. Same goes with account and ledger also. Now let's say user has some dependency on the account service where it needs some data from the account service. So what it is going to do, it is going to subscribe to the event where account is publishing the account entity. But here is the catch. While consuming that account entity, it is not going to create the entire entity because user is not interested in all the attributes of account entity. Probably it will need couple of attributes, right? So what it is going to do, it is going to create a RAID replica of the account data in its own database. So far so good. Now account has published account information onto the message broker, that got published, user has subscribed and it has its own copy of account data. So same goes with account, same goes with ledger. Now what happens? While doing the communication, the services are able to do it all together. Now what exactly is reactive in this? So let's try and apply our principle of isolation. First, isolation in state. So isolation in state, I am able to access this microservices using only my API endpoint. There is no other way. I am not accessing the database or anything else. Then isolation in space. All these microservices are deployed independent of each other. So there is no dependency on each other for the deployment. Then isolation in time. So how the communication is happening? It's happening over the message broker. So I am not communicating with the services are not communicating with each other directly. So isolation in time. Now the most important thing, isolation in failure. How exactly? Let's say my account service is down. Okay, it's completely down, and my user service, user microservice, has 10 different operations, in which out of those 10, 4 are dependent on the account service, where it needs certain data from the account service. So far so good? Everybody with me? Okay. Now, if my account service is down, my user service has a RAID replica of that data from the account. So now what will happen? Instead of waiting for getting the data from the account service, it is going to use its own copy. So that way, my user service will be able to do independent execution of all its operation, though it has certain dependency of the data on account service. So that is the beauty of reactive. So using the reactive way, we avoided the dependency and my system is still performing. I know that if my accounting service is down, partial functionality will not work, but at least the user and the ledger services will be able to execute their functionality with 100% uptime. So that is the reactive approach in order to develop any microservice. Okay? Now, oh, this is a cool concept. We should start applying. Tomorrow, once I go to office on Monday, I'll tell my manager, hey, I learned about the reactive microservices. Our microservices architecture need to be changed to reactive. Is it so? Yes? No? Still confused? So before applying any reactive way, we need to ask ourselves, is that approach is right for our architecture? Are you working on a mission critical application? Then maybe. Do you want to achieve the isolation in your services so they can execute independently? Maybe. If you wanted to loosely couple the microservices and have a decentralized architecture, because many a times we end up developing the services which will have a dependency on one service. So we need to ask all those questions, evaluate first, and then only go with the approach. And if we look at some of the early adopters, So if we look at some of the early adopters, Netflix, Amazon, Hotstar, Flipkart, you guys must have seen the big billion days recently happened, right? Everybody shopped a lot, right? So many things, mobile phone, accessories, clothes, and everything. Now if you see, once that big billion day sale was online, huge population started browsing that data, right? So what is the first thing you are going to do? You are going to first check the item I want to buy, whether it is available at the discounted price. I want to buy an iPhone. कम हो गया क्या? अरे कितने का हुआ? कैसे? कहाँ पे मिलेगा? कौन से साइट पे? कितने में कम हुआ? So that is the first thing that you are going to look. So in big billion days, the most primary service that got impacted was catalog service, because it was responsible for showing the entire catalog with the reduced price. So that way, they created their architecture in a reactive way so that they avoided that dependency on the other services. And that way they were able to cater the need of the users. Now another example, Hotstar. I know that everybody is cricket fan, right? Yes? No? Yes. Okay. Which is the most interesting match in the calendar year? India versus Pakistan. Now if you want to watch a match, if you are not next to the TV, what will you do? Hotstar. And now let's see, if that live coverage, Hotstar is not able to bring us to us, and there are issues, what will you do? You will not subscribe to Hotstar. Arey, uska performance acha nahi. It is all the time down. It buffers a lot. I don't get the live telecast. So that is the problem. If Hotstar is not able to deliver what they are saying, then it will create a problem. But Hotstar already architecture their entire system in such a way that they'll be able to cater this sudden spike in the user views. So they used to call out some tsunami testing. So they used to do a tsunami testing on their entire architecture to see if that entire thing will be able to cater the need. So these were the different market leaders who has adopted to the reactive way to implement their architecture, whether it's a streaming service, whether it's a e-commerce or the banking system. Okay, so today we looked at evolution, what is a microservice, reactive way, and also we have seen our use case. Now I hope that Bhushan will be able to transfer 10K to Priyanka. Alright, so that's all about for today's agenda. Any questions? I think we have a limited time, so we'll be able to take a couple of questions if you guys have any. Yes, ma'am.
Okay. We use fallbacks and all. But I would like to know how are we going to implement bulk hedging, because I was curious. We are just reading through it, but what is the implementation part being how are you going to implement that?
Okay. So bulk heading, it's not something like a different framework or library you need to use. Basically, it's a design analogy that you need to apply. So while designing your system, you need to think about different isolation points, where you'll be able to isolate each one of your service from each other. So that is the basic principle of bulk heading. So you need to think what are the different domain entities that you are working upon and how they are interdependent on each other, and try to isolate them from each other, and that way you'll be able to implement the bulk heading. Okay? Thank you. Any other? Yes?
So, hi Bhushan. So, when I learned about this reactive microservice, so like in our example, the user is having its own data copy or a replica of an account here. So, I'm trying to understand what is that problem which will not get solved by using cache here, and why reactive microservice, what reactive microservice will play a role in. So, because cache is somewhat like you will store some data in a cache, and at high level I am seeing it as a cache because I am having a local replica of that account. So that one I wanted to, can you elaborate that?
Okay, sure. So when you say you wanted to implement the cache implementation, let's say the same use case of the banking. If I start putting all my accounting data into the cache, eventually the cache will be full. Because you are not aware who will do transaction when and which accounting data I need to use. But at the same time, you will have a cache mechanism, first pull from the API, if it is first pull from cache, if it is not available, hit the API. But at the time of hitting the API, if the API itself is not available, then it's of no use. So when we are creating copy in the database, I know that we'll be creating a duplicate data, but your system will be independent. And in this case, you don't need to have the entire data copied into one database from one service database to another. It will be only read replica. And the reactive way, it's not about new design methodology. It's basically about isolation and creating independence between the two microservices. So that way you'll be able to copy the data and have the independence.
It will have a latency in the data, right?
Exactly. Now latency is kind of a knockout argument in every architecture design. But look at the cost that you'll be having. If you are having synchronous communication and there is a failure, huge loss will be there. Your data will be lost, your messages will be lost. But with the eventual consistency, at least you'll be able to gain that particular thing. For example, if you're doing IMPS transaction from your net banking app, sometimes you'll get a quickly the message will be amount is credited, but sometimes there is a delay. So that is one example of eventual latency. We can work with it. Only one thing is that we need to be very smart and we need to carefully address all the issues with the eventual consistency. Okay?
So like you said in previous slide, user service have the read replica of the account service, right?
Right.
So is it good practice to have user service have a replica of the account service as well as the other services? Because it look like the monolithic architecture, right?
Okay, that's a very good question. Because your concern is we are duplicating the data from all the services into the single database. But look at the big picture. So I'm not replicating the ledger data into my user service because user service doesn't need any ledger data. But I'm only replicating the account data because I want to make my user service independent of the accounting service. If accounting service goes down, my user service will still be able to execute it. So that way I'll be not replicating the entire data, I'll be replicating only that data. Okay? Okay. Thank you. So I think due to time constraint.
And lastly, are we supposed to maintain that duplicate data? Because my job is done, my service is up and running now.
Yeah, but as we are communicating asynchronously, whenever there is an insert update happening on that particular data, it is still going to get published onto our message broker. Then I need to consume and make sure that read replica is always updated. Okay? Okay, I think we are done. Okay. Thank you everyone for being the participant. Thank you.
Thank you, Bhushan. That was a very good session. Right, Harsila?
Yes, I have now much more clear understanding that how we can create loosely coupled architecture with microservices and how we can leverage this knowledge if in case any need arises.
Yeah. Okay. Tell me, Harsila, have you ever thought of cloud apps without containers? Or are you aware about the evaluation of the cloud infrastructure?
Yes, I do. I think it's unicorn.
Yes.
I would like to call our next speakers, Rutuja Kaur and Shravan Khed. Rutuja is a passionate coder having versatile experience with working with travel, hospitality, media entertainment domains. And Shravan has an experience in pharmaceutical and digital learning domains. Please welcome Rutuja and Shravan on stage.
Don't worry guys, this is last session before lunch, so please be seated.
Hello everyone, I am Rutuja.
I'm Shravan.
So we are here to give a tech talk on our topic, unikernel. It is also called as container 2.0. So I will quickly share agenda for our topic. So in this session you will understand what unikernels are, how they are different from containers and VMs. We will also see their advantages and disadvantages. In this session, we will be also showing you few implementation of a unikernel, and followed by this tech talk, we also have a tech booth. There you will get an opportunity to see the running implementation of a unikernel. So before we move ahead, I would like to know if any one of you have ever heard about this term unikernel before. You can raise your hand. No? Don't worry, you will understand it. Can anyone tell me what is kernel?
It is basically a core part of any framework, like it is a heart of, we can say, as a framework.
Correct, absolutely correct. It's a heart of an OS. So we all have been knowing kernel. We have been knowing it since our academics. But this is unikernel, a new topic altogether, right? So being a tech person, whenever we hear anything new, the first thing that pops up our mind is, what is this, right? So in this session we will understand where it is coming from and what is the motivation for it. So we will start with the evolution of cloud application deployment. So our application deployment has evolved a lot over the time period. So initially there was an era of physical server. So when I say initially, I am almost talking about the time when people used to live in peace and harmony. Okay? So that time, if I had to host an application, I had to purchase a new server. And that particular server we used to deploy only one particular application. Right? So if I have to host n number of applications, I have to purchase n number of servers. Right? And then we have to install operating system into each of them. So these servers consumes lot of power and they produces heat. So we also have to set up a cooling system. So we were facing a burden in terms of cost, storage and network insecurity, network infrastructure, sorry. So our entire IT industry faced this problem. And then to solve the problem, then there was an era of VMs. So VMs solved our problem to some extent. Because with physical server, we were deploying only one application on a one server. So we were hardly using the physical resource. The utilization of the physical resource was limited to 6 to 10%. So with the VM, here you can see, we are using hypervisors. So hypervisor basically allows you to have multiple VMs on a single server. So now, with the help of this VM, we can deploy multiple applications on a single server. So here we are trying to increase the utilization of the physical resources. So we have increased the utilization from 10% to let's say 50 to 60%. So that's the benefit that we are getting with the VM. But when we started using VM, we observed there are fair amount of disadvantages as well. Because each VM uses their own operating system. They have their copy of OS. So we have to install OS and which uses significant amount of RAM and CPU. These VM images are always bigger in size. They are in GBs. So whenever we thought of migrating them or whenever we thought of taking a backup, it always took time. And because they are bigger, whenever we tried to spin up the instance, it also takes time. So to overcome the problems of VM, now there is an era of containerization. So here we are talking about virtualization in terms of operating system. So here your entire application will reside inside an isolated environment. We call it as a container, right? And all containers share this common operating system of the host. So since they are sharing stuff, they are comparatively lightweight as compared to VM. And they are even giving us a better performance than VM. So we all are using containers till today, right? We are happy with it. They are giving us better performance. But have you ever thought of cloud application without containers? Anyone? You must ask why, right? If it is already good, giving us advantage, then why should we think about any alternative? Let's start with a problem statement. Suppose, consider a scenario, I want to run an application. Any simple application. So this is the detailed view of the container stack. This is the detailed view of the container stack that we have seen on the previous slide. This is how we are running today. So we have a hardware at the beginning. Then we use other driver because hypervisor needed. Then we put OS that supply user processes. On top of that we put Docker. So inside Docker again we have application config, language runtime and shared libraries. So this is what we are running every time. I just want to run one simple process. And what was my aim? I just want to run single application using single user on a single server, right? And if you see, there is a lot of redundancy in terms of isolation as well. We have isolation of the hardware at the bottom. Then we are using hypervisor. That means we are isolating virtual machines. We have a user process isolation, that is OS basically, that is isolating user processes. On top of that, we put Docker. Docker is again doing same. It is isolating user processes. And at the top, we have application which is doing isolation at user level. So now you must think, why is this so complex? For instance, why kernel is so complex? Because main job of kernel is to protect. It has to protect user from another user. It has to protect application from application. It also has to protect user from application. So in early 50s, when we started using computer, that time we were having mainframes, big computers. So that time we couldn't afford to buy one big computer and just run one application on it. So we needed to share. And then there was time sharing computer in 50s, 60s, where I have to make sure if I am sharing my computer with you, you are not going to run on my memory and kill my application because I won't do it for you either, right? So we have to do all that orchestration and set permission on operating system because again we have to protect. But that's not the case nowadays, right? We can go to market, we can purchase our own laptop and we can run our application on it. We can even run it in the cloud. But even talking about the microservice architecture, we are actually doing lot of sharing and duplication over there. Our kernel uses lot of driver which we are not even using. For example, we have a driver for USB. We are not using it, right? For Yum is a package installer that we use for Red Hat Linux. It is basically used to install and update packages. So you get lot of chunk in your computer with this Yum. And you are not even sure what you are exactly getting, what you are not getting. So long story short, we have a many thing in our computer that we are not using, but it is taking space on our disk. So in terms of security, it actually creates huge surface of attack. Because we have a lot of stuff over there. And it is very difficult to provide security for such huge surface of attack. Even with the microservice architecture, we are sharing many things. We share kernel, memory, file system. And the only thing that is protecting us is a kernel extension like C group. So C group is basically control group that is used to control resource usage across the group of processes. And the scenario over here will look like we have a big house, we have a door and windows, and what we are doing is we are simply putting a lock and we are thinking we are safe. But that's not enough, right? There are other ways to get in. So this is how we are thinking we are safe. We are putting lock and we are thinking we are safe inside. But Babu Bhaiya is trying to get in from other ways. This is little problematic, isn't it? There is a lot of inefficiency in a stack that we are using today. And question here is, how did we get here? And the answer, in my opinion, would be pure evolution. Because we started with the mainframe, then we went to the personal laptop, all the way to the Internet of the Things. And as a community, we always focused on compatibility rather than efficiency. But now we know the problem. We have to fix it. But the question is how? What can we do to make it better? Can we rewrite the existing kernel system? What do you think? Should we try rewriting the existing kernel system? It's a bit complicated, right? Then does it make a sense to write a new kernel from a scratch? Can you think of writing new kernel from a scratch? This is what you must be thinking about me, right? But I'm not crazy. Proof for that. This is a guy who wrote a kernel operating system, Linus Torvalds. And as per him, anyone can write a tiny kernel with less than 1 year without any prior experience. That's what he did. And exactly that's what unikernel ecosystem did. They wrote a new unikernel altogether. So let's try to understand what is this and why it is so good. So this is your traditional approach. In the beginning you have kernel at the bottom basically. On top of that you put all your libraries. For example, we have library for database, we have library for containerization, we have library for character encoding. So we put all such libraries in the middle. On top of that we put our application. So it doesn't matter which application I want to run. The stack is always going to be same. There are always going to be all the kernel. There are always going to be basically all the libraries and the kernel. But what unikernel is saying, what if I only take the application and see what it really needs? For example, I don't need USB drive, right? So I am not going to put it inside. That would be the waste of resource. So I'll only take what is really needed by my application. So this is what unikernel is doing. For example, we have this library libHttTP. We have this big library, but only white part is utilized by the unikernel. Because I am not needing the entire library, I might need only 4 to 5 functions from that library. So I take only that much. So this is how they are doing. They are only pulling what is required from the kernel and from the library. So this is the difference between traditional application and unikernel application. The traditional application, you can see the stack is quite bigger, whereas in case of unikernel, the stack is reduced. Can you relate the size difference over there? Now let's try to understand how they are doing it. So whenever they decided, basically when they decided to architect this unikernel, they decided to support only one user and one process. So if there are not going to be multiple users, I don't have to set permissions. They decided to support only single address space because there is always going to be only one process running at a time. So I don't have to maintain multiple address spaces because that's not needed, right? I can run my application directly into kernel mode. I don't even need kernel rings because that is the only thing running over there. Why do we usually need kernel ring? Because I am running my process and you are running your process. And if my process is doing something nasty to the operating system, or I would say to the host itself, then it might be killing your process, right? And you will be influenced. But since we have only one process running over there, even if they kill, they'll kill only my process. That's it. Nothing else will be influenced, right? So this is how now you will understand basically. If we make this choice, we can be very smart about taking out the things that we don't really need. And you will discover we don't need quite a lot of stuff. So this is what they are saying. We don't need context switch. We don't need kernel mode, user mode. We don't need multiple address space. And we can be very keen about what we are going to put into our operating system. So this is how the multipurpose OS and unikernel difference will look like. With multipurpose OS, you will see we have a user space and a kernel space. User space is used to run application software. Kernel space is again dedicated for the operating system kernel or kernel extension. And to maintain the difference between them, we need kernel rings over there. That's not the case with the unikernel. We are supporting only single address space, so you can see everything is so simple and sorted over there. This is the basic diagram that will show you what are things you will be needing if you are going to create a unikernel. So on runtime, we will be needing hardware because I would like to know where you want to run on. You will be needing language runtime. And on application side, you will need application binary, config and dependency. We have to put them all together in a packaging tool and then your unikernel is ready. So unikernel is basically a bootable unit. You can run it directly on a bare metal, but that would be the waste of resource because it's very thin. So we run it on a hypervisor. And hypervisor gives you something very unique that your OS doesn't provide. It gives you hardware separation. That means your CPUs are separate. And it is very much secure. I would say it is much more secure than taking a bare metal, put an operating system and then put a Docker on top of it. Because there you don't get hardware separation. And VM is basically a machine. So you can continue using your own hypervisor is basically a machine. So you can continue using your own hypervisor and everything else will look exactly same. For example, you want to support a memory, it's already there. You don't have to reinvent anything new because it's a VM. So what we did over here, we took only what is really needed for our application. We remove all unnecessary middle layer, and this is it is very easy to reason about because here we are talking about only 2000 lines of a code for an operating system. So we build a hypervisor and we put a very thin wrapper of operating system. We call it as a library operating system around your application. So here we have less code. So So there are definitely going to be less bugs and we will achieve a very high performance. So this is how unikernel did isolation and specialization. On the left hand side, you can see all the containers are sharing the common kernel. But whereas in case of unikernel, each application is getting a separate hardware. So this is the isolation and specialization that they are achieving with the unikernel. So there are two types of unikernel. First one is clean slate. This one is restricted to single language use and it allows language specific VM to function. Examples are Include OS, Mirage OS, Runtime.js. There is another type that is legacy. This one is implemented using POSIX standard, so it can run on all POSIX compliant application and services with just minor configuration change. And examples are OSVs and nanos. Now I've been talking a lot about hypervisor. Let's try to understand what is this hypervisor. Hypervisor is also called as a virtual machine manager. It allows us to create and build multiple virtual machines. So basically it allows single host computer to support multiple guest VMs. And there are again two types of hypervisor. First one is native. This one is run directly on a hardware, so it can access their CPU and memory. We have a second type, it is called as a hosted. So this one is designed to run in our traditional OS. So we have a hardware, on top of that we have our operating system, and hypervisor will be another layer on top of OS, which can support again multiple VMs. So this is the stack, how VM container and unikernel will look alike. We will compare them considering the multiple aspects. I talk about the OS usage first. So application running on the VM can have multiple OS because each VM can have their own copies. Whereas in case of container, all the containers share the common OS of the hardware, host hardware. In case of unikernel, we don't really need that. It uses library operating system and it has only tiny footprint. So no, we don't need the entire OS. Talking about size, VMs are always bigger in size. Containers comparatively have less size, they need few megabytes. But unikernel have very tiny footprint. Talking about boot time, VM need a few minutes to start because it has significant amount of process running in the background. Whereas container comparatively need less time, so boot time for container is in few seconds. But with unikernel, because of library OS and tiny footprint, the boot time is even reduced to few milliseconds. Talking about memory, VM almost uses everything from their host system, so they need lot of memory. Containers comparatively need less memory and unikernel need less than 10 MB of RAM to run. Now let's check the use cases, which one to use in which scenario. If your application is going to use most of operating system function, then go for VM. If you want to increase the number of running application with minimum number of servers, then go for container. If use of operating system is not mandatory, it's not compulsory, and your application is really lightweight, then you can always go for unikernel. IoT is a classic example to use the unikernel. Example of VM is KVM and Zen. Example of container, as we all know, Dockers. Example of unikernel, Mirage OS, Include OS, and Unicraft. So this is how container deployment will look like. All your container will be sharing the common host OS. With VM, it always runs on top of hypervisor, and on top of hypervisor we will have virtual machine. Each VM will have their own copy of OS. In case of unikernel, on top of hypervisor you can directly run your unikernel and app. So even stack size is reduced with the unikernel. This is the research paper that we have been referring for our tech talk. So they came with certain benchmarks, so I will quickly walk you through that. So as per them, unikernel always exceed containers with respect to time, response time and speed. It also firmly surpasses them on single core performance type 1 hypervisor. As per the evolution, unikernel perform 16% better than their respective container for Python and Java when they build REST API stress test. It is even better with Go where they perform 38% better. They are saying unikernel is always an advantage over the container in a scenario where you have frequent context switches like REST services. And unikernel is always a great deal in terms of memory as well because they don't need the entire operating system. So we have seen a lot about unikernel. Now let's take a look at few unikernel implementations. I'll invite my co-speaker Shravan to walk you through the next slides.
Thank you. Hi everyone. So I'm Shravan and we are talking about unikernels. So because I have briefed you about what about unikernels and you might have got an idea of what unikernels are. But we have it's an idea, right? Unikernel is not an implementation; it's an idea. When you talk about the implementations of the unikernels, there are certain implementations like NanoVM and Unigraph that we are going to see in this session. So we will start with this one, and I will say that we are not advocating any of the implementation, but yeah, it depends on your need and what you want from the unikernel concept. You can use that kind of implementation. So going along the slides. So first is the NanoVM. This kind of unikernels don't use SSH. There are the boot time for the stripped and unstripped kernels. For unstripped kernel, it is around 195 milliseconds and 72 for stripped kernel. So basically, stripped and unstripped kernels are those where you have kind of debugging tool attached and where the another one would have that. That's why you see this difference. And there is if you use NanoVMs with Go, WebSphere and AWS, it shows around 3 times better performance. So going to the next slide. So for the NanoVMs, we use ops tool, and with this ops tool, if this needs an installation. This is a kind of orchestration tool for the NanoVMs, and this is the installation for the ops tool, and you can check the version of the ops tool. This is basically a curl command. Download some stuff from internet and install ops to your local machine, and it also needs QEMU KVM and QEMU utils. This tool also manages your images that you create out of the tool and manages those images. So ops provide you already existing packages. If you see there, we are using the node for our application, for our exploration that we did. Here's the command to create the ops image, and this is listed. And you see here's the image got created with the unikernel SCNXT and 2020 IMG. So this is an image that could be used on any other hypervisor to run the application. So this is the config file that we use, and we have passed this the reference to this config file into the API while creating the images. So this config file consists of directories, runtime configuration like codes, and the memory that are going to be used. So very next image is in the last slides we have created the images, but this is about the instantiation. So when we hit ops instance image or ops instance command, and it gives you this instance that is running, and you can list this running instance on your machine with this command ops instance list. And here, if you give a call to this kind of instance, you will see that this is the instance that we have called, and this instance was running on our regular VM, and we were using MongoDB with it, so we got a successful response. Now talking about the image composition of the image that we created using NanoVM. So here it is. This is the kernel folder of this image, and if you use ops image tree, you will see this kind of output, and this is whole about this is the stuff that is included in the image. And while if you check the kernel folder that is here, there are only limited files. These are the shared which are available. But in the very next slide, when I try to file LL command for the same folder in the normal Ubuntu machine, this will here you will also see there are lot many stuff available here that I could not even list on this screenshot. Another tool is the Unicraft. So Unicraft is also similar kind of tool that creates the images. It supports multiple platforms like RAM, KVM, Linux user space. So talking about this one, so this needs references or the repository or the system that is associated with the craft to be available on your system before you start using the images out of it. So here is the command craft list update. If you hit this command, you will get this kind of output. This says that this stuff will have reference on your system, but not they will be actually copied down to your local machine. They will only get a reference from the GitHub craft Unicraft page. Next is the craft list. If you hit the craft list, these are the multiple things that are available here. And in the craft we have three stuff, that is platform, libraries and applications. So things that you see in the green are being actually used while creating the applications on using this craft tool. So as I mentioned, we have three things associated, that is platform, libraries and applications. So this is the Hello World application that I was using on that machine. And if you see here, there is a GCC. This was a C application, so it has GCC used. Going to the next slide, how you create build out of it. So we hit a craft configure command, and with the craft configure command we have following as I discussed in the very beginning, that we can have multiple target images. So you are asked which target image you need. So if you hit one of them, you will get built accordingly. Now hitting the craft, creating the build out of it. So once you configure the craft for a specific target, you will get a build. You can hit the craft build command, and accordingly you will get a build inside a build folder, as you see here. This is a craft table file which has all the associated targets and platforms it's a Linux, KVM, and everything. And there are the multiple combinations with the architecture. So there are multiple images, multiple target images are possible with using this YAML file. There's a craft menu config command that gives this kind of UI to you for the selection of the architecture, platform, as well as library or configuration build options. So we try to run the image, this kind of image. So when we hit craft run, you get the images that are available on there directly. So you can select one of them, and you will see this kind of output. This was a C console application, and we have also explored running a Python API server using Unicraft. So it is here. So we are using pretty much same commands like craft build. So when you run this API, we have part of we have part of memory, we have network configuration here, and when we try to hit this API from here, we get a successful response. So this is all about the Unicraft. There are some other implementations also available, like Mirage. Mirage is similar to we have NanoVM, as it is using code. The Mirage is using OCaml. There's an include OS that is majorly deals with the applications with There is a runtime base that is handling the JavaScript related project, but it is no longer maintained. But yeah, it is listed on the website. There are some others like OSP and ClickOS. These are the applications and company which are backing the unikernel research. So thanks to them. These are the contributors who contributed and brought this research and this session to you. Thank you so much. He's our session guide and he guided us through for the research. These are the few references that we have used for our research. For question and answers, we are available on the tech group.